All right, we should be good to go. Just got to connect to TikTok. TikTok is finicky. Howdy, howdy, everybody. Cat hair in my nose. Welcome, welcome. Hope everybody's having a good Wednesday. That's what today is, I think. Today is Wednesday. Just gotta double check some things really quick. Make sure I'm not missing any important emails. Make sure I'm not missing any meetings. I do have a meeting today at 11:30, so I will have to cut off the live a little bit early. So I'm thinking I'll cut off the free answer session at like 10:30, and then I'll run the members only section till 11:15. So a little bit shorter on that, but you know, I do have this meeting, so yeah, PST, yeah, of course. Let me just double check that I got the meeting time right. Yeah. Oh no, I have it for 12:30. Actually, no, we should be fine. Oh. Yeah, I have it for 12:30. So we should be fine on that. Now let's hide the URL for now because we're not in the Discord yet. We are indeed physicsing. Yeah. Why did Zoom just give me a pop-up that like, oh, take notes on Discord? I hate that. I hate that a lot. All right, let's answer. What's potential energy formula? That depends on what thing you're talking about. So if you're talking about, say, electromagnetic or electrostatic potential energy, then it'll be the Coulomb potential energy, which is something like the charge divided by the distance. If you're talking about something else, you'll get a different formula. Do you think Bob Lazar element 115 claims are legit or not? No, they're not legit. Is it true electromagnetism and gravity unite in high heat? We don't know. We don't know. What's 9 plus teen? 19. Would you recommend I do a photonics module or quantum computing quantum computing intro model for my next semester? That depends on what you want to do. Are you interested in number theory as well? Not so much. Why do tall people punch harder than short people? I don't know if that's like necessarily the case, although what is the case is that tall people are going, if they have longer arms, they're going to be able to accelerate their fists over a longer period of time or over a larger distance, so they can apply more force. But for the same length arms, it should be the same. Why is physics so religious in its assumptions? I don't really understand what you mean. Why are colors the way they are? Is there a benefit, or is it just how the universe is? Well, so colors are things that like we evolved. Colors are like neurological phenomena that, you know, are kind of the internal experience that corresponds to the external stimuli of photons hitting your eyeballs. So that's like an evolutionary thing. They're not really a feature of the universe in that way, or of the external world anyway. Could a black hole simply be a really big neutron star? I mean, in a sense it is, except it's so big that it becomes a different thing. Is math invented or discovered? I would say invented. Postdoc or sellout? Neither. No. It depends on what you want to do. If you want to make money, the postdoc route is not the way to go. Do you know quantum physics? Yeah, I do. Yeah. You weren't live yesterday. I waited and waited. I started to worry something was wrong. I did mention in the Discord that I had to cancel the live stream. We assume, for instance, materialism, but it's still a religion. Oh no, materialism isn't religion, unless you have like some extremely ad hoc definition of religion. I should jump down to the bottom because I'm a bit behind. Do you believe in hard determinism? In a sense, but it's like a quantum version of it. Why would a horizon being flat prove a planar Earth? Wouldn't there have to be a curve if you were above the circle? It depends on whether they think that the Earth goes on forever or if it doesn't. If the Earth goes on forever, then there shouldn't be a horizon at all. If the Earth has a finite extent, then the horizon should be curved. But they don't know that. Why do black holes radiate away faster when their mass is lower? One way to intuitively understand this, and this is roughly right, is that you can think of Hawking radiation as originating from stuff inside, quantum tunneling outside. And so if the mass is smaller, if the mass of the black hole is smaller, then the quantum tunneling is easier. Basically that. Because there's a less severe barrier. Math was always there, we just invented the symbols valid. I don't agree with that take. Did your cat mellow out? Yeah, at least last night. Are physicists trained in computer programming? It depends on the physicist. Did you hear PhD Freeze call on Ian's show yesterday? If only. I was busy talking to an insurance company. What is emergence? I mean, it's a little bit hard to define, but emergence is generally, or is roughly speaking, it is the phenomenon in which you have new features, like qualitatively distinct and new features arising at one scale that aren't present at a smaller scale. Would a black hole become a neutron star again when enough mass is radiated away once no additional mass is falling? And no, they always stay a black hole. It's just their event horizon shrinks and shrinks and shrinks and shrinks. What laws of physics or not work within a black hole? So the thing is we just don't really know what's going on inside a black hole. We can make inferences about what's going on near the event horizon, like on the near inside of a black hole, but we can't really say for certain that that's what's happening. Can you explain the phenomenon where a superconductor makes a magnet float? Yeah, so a superconductor, a non-ideal superconductor, has basically tiny little gaps, like tiny little gaps in the superconductor. So what this means is, so classically, a perfect superconductor expels all magnetic fields from it. So you can't have any magnetic field inside of a superconductor. However, real superconductors, they basically have little gaps, so they can let some magnetic fields through. But they can only let some magnetic fields through in very particular paces, kind of where the gaps are. And so what happens is that if you have a magnet, or if you have a superconductor, and then you have a magnet, you can force the magnet so that the magnetic field produced by the magnet passes through these kind of gaps in the superconductor. And then, because those magnetic field lines can't pass through other places in the superconductor, there's a force kind of trying to pull those magnetic fields back in line. And that causes the magnet to be pulled back in line. What do you think of Thomas Young? He was quite a smart scientist. Can you explain the phenomenon where... Oh, I already explained that. I'm very much interested in particle physics and fascinated by it. Where should I start to learn? Pick up a physics textbook. Are you going to watch Schmidt's video on his cumulative case for God and maybe make a short review? It'll be like 12 hours, so I probably won't. I'm probably going to demand that somebody else watch it and make a short review, and then I will watch the review. I'm currently doing my master's in astrophysics. Is it possible to go into theoretical cosmology and topics like unified gravity? What all topics would I need to study? I love your videos. I mean, it's possible. Like, you can always spread your wings, but the thing is when you are in like especially in a master's, you have time. This is like the time when you can choose your subfield. So just start taking other classes. Take a GR class, which you probably are already taking. You should probably take some quantum field theory classes. That's pretty necessary for theoretical cosmology. Oh. Do you think that creating a theory of everything lies within the realm of human capability at all? I hope so. You work on quantum gravity? Occasionally, yeah. How do you refute the contingency argument? So the contingency argument either collapses into necessitarianism or there is one brute fact. There's not really a way around that. I have a hard question that 2 astrophysicists have failed to answer so far. Would you be inclined to? I mean, you can ask your question, but this seems like the kind of thing that a combative person would ask, so I'm probably not particularly interested in doing it as a debate or something. Isn't the event horizon just a point where the escape velocity is equal to the speed of light? If so, doesn't that mean that at the event horizon the photon is in orbit around the black hole? No. So that's not quite what the event horizon is. The photon can't be in orbit at the event horizon. And in fact, this is kind of like obviously the case. If you are moving at the speed of light, if you're moving at the escape velocity of the Earth, that is a different speed than the orbital velocity of the Earth at the same altitude. Escape velocity and orbital velocity are different. So, in fact, around a black hole, there's something called the photon sphere. So the photon sphere is exactly where photons can orbit. So this is about 50%, or it's not about, for a non-rotating black hole, it is exactly 50% further away from the center than the event horizon is. I've never understood why energy inside of something gives something mass, but the total energy doesn't. Well, the total energy does, but it's the total energy that can't be removed by changing reference frames. That's the point. Or by doing gauge transformations more generally. In KSP, what's the most DV efficient way to change my inclination significantly around Joule? So, I mean, first of all, you could always use gravitational assist to do this. Those are always going to increase your efficiency. However, the most efficient way generally to change your inclination is to increase your periapsis so that it's, increase your apoapsis so that's very, very large. And then at apoapsis, do your inclination change there. And then you can reduce your apoapsis afterwards. What do you think about constraint being the process for physical realization or emergence? It's an idea. What do you think of your debate with Apollo? He tried to Philbro jargon dump me, but it turns out I'm too good faith to let that happen. And when that happened, he started making blunder after blunder. Does Olber's paradox and light received account for expansion? Essentially, does expansion outrun the speed of light? You don't necessarily need expansion to solve Olber's paradox. You need one of the following things. You need either a finite speed of light or a finite age. That's basically all you need. And you can have both. In our case, we kind of have both. So. Sorry, I have to jump down to the bottom because I'm a bit behind. Are we causing global warming by destroying the ozone layer? We're not destroying the ozone layer anymore. Why do we not model orbitals? Why do we not model other orbitals other than hydrogen? Like, because there's not an analytic solution for the other orbital or for other atoms, right? So for hydrogen, you can just solve the quantum mechanical system analytically. It's fairly straightforward. You learn to do it in your first quantum mechanics class. But once you add 2 electrons like you have in helium, there's no longer an analytic solution. And so that's why we do it for the hydrogen atom. Opinions on solar gravitational lens. It's a very interesting idea. I hope that we can eventually do this. I think it'd be super cool. It's a little bit far-fetched at the moment, though. When did you start studying physics? Well, properly when I was 18, when I enrolled at undergrad. Don't get the idea that if you're able to watch someone cross the event horizon, they would freeze in time. Well, the point is that they're crossing the event horizon, but the light coming from the event horizon is slowing down. It has to crawl all the way out of the event, all the way out from near the event horizon. And so that light will just take forever to get to you. The light from them crossing will take forever to get to you. Because as they get closer and closer to the event horizon, the light takes longer and longer to get to you. Do you believe in God and Jesus, and why? I do not. Do you think the society today is future-oriented to advance in core physics? I think mainstream technological developments today are much more capital-oriented rather than innovation-oriented. Well, yeah, that's true. How do black holes spin? Well, look, so in principle, a black hole is like an object. It's like a thing, and the thing is spinning. And we know it's spinning because it used to be a star, and the star was spinning, and angular momentum is conserved. How do we make the math side of M theory? I don't understand what that question means. How would they not just vanish as there is nothing for light to reflect off? I don't know what the question is about. Do you think a white hole exists somewhere in the universe? No, I don't think so. How much energy would it take for us to remove or add protons from a nucleus to change the element? Well, we do this all the time in particle colliders. In fact, there was a news article that came out, or a bunch of news articles that came out quite recently that was talking about how we finally turned lead into gold at particle colliders, and we can do this. It's just really inefficient. what is a Hilbert space? It is an abstract mathematical space in which it's a kind of vector space. It's a complete inner product space. I can give more details, but it's not going to be super helpful. It's an abstract mathematical space that holds vectors, and those vectors can... The reason why this is useful in physics is because those vectors are quantum states. What will you do if retrocausality is proven true experimentally? That's a great question. I don't know what I'll do. I'll be very perplexed, though. If a photon has a velocity perpendicular to the surface of the black hole, some distance outside the event horizon traveling towards an observer redshift, can it be seen? Well, no, if the photon's traveling perpendicular to the observer, then no, that observer can't see the photon. Is it better to learn from research papers or physics textbooks? It depends on where you are in your journey. If you have a PhD, a textbook will sometimes be useful, but you'll learn more from research papers. But if you don't have a PhD, then you should probably be reading textbooks. Do you think it's possible laws of physics only apply to our universe? Well, yes, kind of trivially, but I also think that our universe is the only thing that exists. Rotating Kerr black holes behave differently, but right? Can you explain it a bit? Yeah, so a rotating Kerr black hole, there's essentially different orbital radii for photons depending on which direction they're orbiting in. A rotating Kerr black hole, so all Kerr black holes are rotating black holes. That's what a rotating black hole is. Or rather, realistic astrophysical black holes are approximated by Kerr black holes, and a Kerr black hole is an idealized solution. Anyway, the point is that when you have a rotating black hole, it kind of twists the space-time along with it. And so it is, in some sense, easier to orbit with it than it is to orbit against it. And so you would have to be further away if you're a photon to orbit against a rotating black hole, whereas to rotate with it, you can orbit a bit closer. Is it possible that the next revolution will come from someone initially indistinguishable from a crank? I suspect not, no. Could the momentum be conserved via the ejection of mass during the collapse of a star? It could be, but we know that that's just not enough. Like, we can do simulations of this, we can observe these things, it's just not enough. Do you have a video on black hole suns? I do. Do you believe the inside of a black hole is infinitely collapsing or something physical, exotic, compact object that might be spinning? I think it's probably something physical. Do you think capitalism stands in the way of scientific research? It depends on the science. Like, capitalism seems to do a pretty good job of actually providing medical research, because there's a lot of money to be made in medicine, at least in the US. But as far as like more basic fundamental research that doesn't have an immediate profit incentive, yeah, I think it definitely stands in the way. If the photon, really this explanation of yours of light slowing as they are emitted from a body entering the event horizon of a black hole, if the photon slows down, doesn't that disprove the theory of constant measure of light speed? So the constant measure of light speed only applies for light that's right next to you. But the light that's escaping from a black hole isn't right next to you, so there's no issue there. I should jump down to the bottom because I'm way behind, but thank you guys so much for asking so many good questions. I appreciate it a lot. How concerned are you about the Colorado River situation? Thinking of moving? I am pretty concerned, yeah. But no, I'm not really thinking of moving. What do you think of theories involving the structure of space-time changing in high energies, like inside a black hole, could change? It is one of the quantum gravity avenues I'll study once I have the math. Yeah, it's the kind of thing that I think is plausible. Oh, when are you going to start teaching us some naive set theory? I won't. What is the explanation of the universe being fine-tuned? I don't know if the universe is fine-tuned. What's the use in someone being smart if they're not rich? That is such a closed-minded view. Like, that's such a shame. Up to how many degrees of freedom do you think CERN can describe manifold? Which manifold? Favorite science communicator? Matt O'Dowd. What's the silliest physics fact that you know? it's not really a fact, but somebody named so there was a paper that talked about black holes being around planets, and I find it very silly that they called them planets. I just find that very funny. Galaxies spin in the same direction? Well, not all of them. They don't all do that. Are you worried about AI's rapid advances and frontier math breakthroughs and that physics might be next? No, I'm not worried about it. Then I'm so confused about the theory of special relativity and the measure of constant measurement of speed of light. Can you explain more? Yeah, so special relativity is subsumed by general relativity. So special relativity says that everybody measures the speed of light to be the same regardless of where the light is. General relativity says actually that's only true in weak gravitational fields. In strong gravitational fields, this kind of range in which the speed of light is the same, this region in which the speed of light is always measured to be the same, shrinks down to a point. So if the light is right next to you, you will always measure it to be moving at the speed of light regardless of how fast you're moving. But if the light is far away, special relativity doesn't apply, especially if there's a large gravitational potential difference between you and the location of the light. Starting my bachelor's in nuclear and particle physics in 2 weeks, could you give any advice? Go to office hours. Your professors are your friends. How exactly have you not found or disproven the existence of Planet 9? So look, it's not a likely explanation at this point because we've seen a lot of we've done a lot of observations and we haven't seen it, but it's possible that there's a very, very dark planet. So planets are small. They don't really emit much of their own light, especially if they're cold. And if they're far away, they're not going to reflect much light either. And so it's possible that there is an extra planet that's perhaps the size of Neptune, the size of Uranus or something like this, that is responsible for some seeming coincidences that we see in some of the kind of comets and some of the Kuiper Belt objects that we've seen. Now, this isn't like we can't prove this conclusively because like the coincidence could just be a coincidence, right? But space is really big, planets are really small, they don't reflect much, they're not very warm, so it could be very, very hard to see. I mean, think about it this way. We didn't have telescopes big enough to see Neptune for till what, the 1800s? And Pluto couldn't be seen until the early 1900s. From Scribble Scrabble with the 10 Canuck bucks. Thank you so much, Scribble Scrabble. The trouble is Earth. Who said this and why? I don't know. Is this a pop culture reference that I'm missing? I don't know. Explain three-body problem if the universe is not tuned. Well, the three-body problem is not like, it's not like a physics problem. This is like a math problem. And more specifically, the three-body problem is just kind of refers to this idea of like a three-body dynamical system and the solution, the mathematical solution for what the orbits are. But the point is that there's no analytic solution for such a thing. But there are numerical solutions, and there's no issue there. We can solve the three-body problem. In fact, we can solve like million body problems. This is what computational astrophysicists do all the time. From William Matz with the $5, why is physics? Also, rip Tom Curry. Yeah, I heard about this. Rest in peace, Tom Curry. And why is physics? It's a good question, but has anybody ever asked how is physics? Good to see you, William. Do physicists believe that a Kugel Blitz is a real phenomenon? It's a real phenomenon that like could exist, but it probably doesn't exist in our universe because there's not enough high energy electromagnetic sources that could produce such a thing. You should know that question. Yeah, I feel like I should. What fundamentally distinguishes a tetraquark cusp from a genuine four-quark state when both emerge from diquark pair production? Somebody read my undergrad honors thesis paper. Look, I haven't thought about this problem in a while, so I don't have a good answer for you. From William Matz with the $2. Okay, how is physics? Good to see you. Physics is fine, thank you. Much appreciated. Have you tried to solve the Navier-Stokes equation? No, it's not my area. Did I say Tom Curry? I meant Tim Curry. You can't study it scientifically and you can't describe its expansion in words or visually? What? It's cool that you don't, but you're not as nerdy as you could be. Okay, that's fair. Do you think physicists could ever prove every event is predetermined or accurately predictable? Did I say Tom Curry? My bad. No, not really. It could be the case that there are things that are fundamentally unpredictable. From Random Tiling with the $5, what was it like working with Professor Majid? The new perspectives on quantum groups he developed in the 90s are very cool. It was really neat. Honestly, he was a great guy to work with. So I had what do I want to say? I had a very positive experience working with him. I met with him quite frequently, like on Zoom, because of course he was in England and I wasn't. But it was honestly a delight, and he actually has been asking to work on something with me again. I just have too many projects going on right now, and I'm not convinced that like the things that he wants to do are the kinds of things that are physically meaningful, so I haven't put a whole lot of time into thinking about them. But yeah, he was a great person to work with, and I'd work with him again. Absolutely. I think he has a very, very interesting way of thinking about things. I think he has very, very strong insights. Good question. What's the appeal of sterile neutrinos? What gap in knowledge do they bridge hypothetically? Well, sterile neutrinos could be they could be dark matter, right? You could have like massive sterile neutrinos that are dark matter, so that would be neat. Do you agree with geometric unity theory? No physicists really do. From Garain with the $5, do you think it's possible computer simulations can solve fundamentally untestable in the real world problems in physics? I want to say no, because the whole point of doing experiments in the real world is to see which phenomena actually is captured by real world dynamics. And if there's a problem that's fundamentally untestable, then it seems like you could just never check if that's a property of the actual universe or if it's just like an artifact of your simulation, right? Is it ever possible to prove that a theory of everything is really a theory of everything? So there is something called the underdeterminedness problem, which is that you can have many theories of everything that all account for the same data. But I think that this, and that's an idea, like it's not been proven that underdeterminedness is a thing. So that it's in principle possible that we will never be able to tell which one is correct. But I think that, like, you know, we could definitely narrow it down to figure out that, like, oh, there is the theory of everything that looks like this. And from Scribble Scrabble, again, with the 10 Canuck bucks. The trouble is Earth. On Earth, there is no poverty, no crime, no war. You look out the window of Starfleet headquarters and you see paradise. Oh, is this from Deep Space Nine? Wait a minute, hold on. Oh, you're checking me on a quote. I don't know if it's from Deep Space Nine. Is the context here that like Earth is a paradise, but the Maquis out there beyond the Federation isn't, and so is that the context here? Like you know, that the rest of the planets aren't perfect, but you know they have all these features. I think that that's the context to that quote, but I don't remember. Oh, it's from Paradise Lost. Okay, yeah. Okay. What is your specific area of focus in physics? I do stuff that basically, if it involves gravity, I'm interested in it. But if it involves data, I'm less interested in it. Do you think the next leap in physics will come from new experimental data or a deeper understanding of our current theories? It's hard to say, because we've been trying to do the deeper understanding of our current theories for a long time, and we haven't made a whole lot of progress. But we also have been kind of stuck on the experimental front because our experiments keep agreeing with our theories. So it's hard to say which one will come first. But whatever it is, it'll be a big deal. It might even come from astrophysics, actually, not experiments, but astronomy, from like observations of like the like dark energy and things like this. Is physics a Jew's propaganda? No, it's a weird thing to say, though. Are gluons real particles, and what are the proof for their existence? If so, why then are they the only force-mediating virtual particles that are real, or are they real but used as virtual analogs? So gluons exist, but Gluons exist insofar as they are excitations of the gluon field. However, it's the gluon field that's working its magic in the inside quarks. Why do neutrinos have such tiny masses compared with the other fermions? This is a great question that we don't know the answer to. This is one of the open questions in the standard model. Oh, I'm going to close the window. Hey, Dr. Blitz, you're just curious, is Blitz your real last name? Yes, it is. And if you want to learn more, go to my website, which is just blitz.phd. You can check out all my research. You can check out, a short about me. Why do you think energy is not something that it exists independently? Because it's a bookkeeping number. It's just a number. What's your opinion on extended Penrose diagrams resulting in things that look like white holes in parallel universes? Kind of like the last gray woohoo area I have in physics. Yeah, they're ideal. They're idealistic depictions of non-physical scenarios, right? Like a real short-shield black hole A doesn't exist, but even if it did exist, it wouldn't be eternal to the past, and so we would have no reason to think that it's maximally extendable. Similarly, an ideal Kerr black hole doesn't exist. And so, like, we have reason to think that the dynamics of stuff that's falling in is going to collapse the Cauchy horizon into an event horizon, and, these are the kinds of things that don't exist. And so we wouldn't see the infinite chain. If energy is just a bookkeeping number, then how do you explain the physical sensation of things like temperature or light? So light is a physical thing, not just bookkeeping. Light is a physical thing, and that physical thing can interact with you, and that causes a sensation. Similarly, temperature captures essentially the average motion of an object, or of the molecules in an object. And if there's more of that motion, then that motion is going to have a higher chance of interacting with your body in a certain way. I don't understand virtual particles. Do they actually exist? If they don't, what are they used to describe? So no, they don't actually exist. At least this is my view. Perhaps it's contentious, but they don't exist in my view. They're merely mathematical tools, or kind of like a mathematical trick that we use to solve quantum field theory problems. So you can think of them as kind of a simplified way of describing a complicated field configuration. So you have like a complicated electromagnetic field, for example. You can describe that in a simpler way as like a whole bunch of different virtual particle states. Over unity devices, is there any basis in physics? No. Photons know whether we're observing them or not, so they're conscious. Well, that's not true. Like, none of that sentence is true. Are there any massless particles? Yes, photons are massless. Used to watch you debate the existence of God. Oh, this is the moderate case? I've seen you. Do you think science leans more towards an initial creation or infinite existence? If you ask physicists, well, okay, if you ask cosmologists, I should say, the people who study the origins of the universe, what you'll find is that most of them are working with some sort of eternal past. Like if they're trying to like model the early universe, they generally assume some sort of eternal past. Now, does physics actually point that way? That's a different question. We don't really have any data that supports it one way or the other. I kind of lean towards an eternal past, but I'd be kind of okay with both. Can I ask about the edges of the universe? You can, but as far as we can tell, there are no edges to the universe. Dumb question, why is it called theoretical physics if theory is just a model? Isn't applied physics also interesting in creating and validating models? No, so there's the distinction here is there are different branches of physics. There's like particle physics, there's condensed matter physics, there's astrophysics, there's biophysics, there's plasma physics, there's nuclear physics, all these different branches of physics which study like different types of physical objects or different kinds of physical systems. And then within each of those, you're going to have the theorists who come up with models to study the things and try to understand like the implications of different observations and things like that. And then you have the experimentalists who devise the experiments to test those models. Sorry, my nose is itchy again. And so the point is, it's not like theoretical versus applied, it's theoretical versus experimental. From Geraint with the $5, wait, I thought virtual particles were just perturbations of the quantum fields that were below the threshold to form a real particle. Yeah, so the point is like a perturbation is just a different field configuration, right? It's not a propagating mode like a particle is. Jumping down to the bottom. If you'd be okay with an initial beginning and the laws of causation and physics, would you assume a creator? No, I think that it's possible for there to be a first moment of time without without there being a creator behind it. So it gets a little bit complicated, but you have to kind of think about this in a kind of a 4-dimensional way, like a space plus time dimension way, 3 dimensions of space, 1 dimension of time. And so one way that you could have this is that you could have pure space, 4-dimensional space, and then somewhere in that space there's time that starts. One of the spatial dimensions becomes a temporal dimension. And I say becomes, it's just kind of like a smooth transition as you're moving through this space. It's not like something that's caused. It's just a geometric relationship. And in that case, you would have a first moment of time, but there'd be no creator. There would just be kind of space or timeless space beforehand. And it's not really before, because there's no before the first moment, but it's kind of like geometrically prior or ontologically prior or something like that. Hopefully that helps. But it does get kind of complicated. Should theoretical physics more properly be called hypothetical physics? No, I don't think so. If you're doing theory work, why would you call it hypothetical? Can you explain the Heisenberg uncertainty principle and how particles act as waves and particles? Well, so, okay, look. First of all all particles are waves. Not all waves are particles. A particle is just a certain kind of wave excitation. A certain kind of wave configuration that's localized. So it's just kind of like, it's a wave, but it's like a localized wave. So it travels like as like a bunched up wave. So all quantum objects are waves. All particles are waves, all waves are waves, obviously. Now, the Heisenberg uncertainty principle is really a statement about waves. So when we talk about quantum physics, the relevant feature here is that the higher the frequency of the wave, the more momentum it has. Now, there's a statement known in mathematics. There's a phenomenon or a process in mathematics called a Fourier transformation. And what a Fourier transformation does is it essentially takes a spatial configuration and it converts it into a frequency distribution, or or I guess it would be a temporal distribution to a frequency distribution, or a spatial configuration to a kind of like a wavelength decomposition. So if you have, for example, the Fourier decomposition of a perfect sine wave in space will just give you a spike in Fourier space because it's isolated to just a single point or a single wavelength, right? However, if you have just a spike in position, so you have an object that's very, 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 very strongly localized in position, well, then you can do a Fourier decomposition of that, and you get that it has a whole bunch of different frequencies, right? It's a whole bunch of different frequency waves added together. And so what the Heisenberg uncertainty principle is really about is it's saying that momentum and position are Fourier conjugates. Meaning that if your state is well described by a highly localized position, then if you want to find the momentum, you have to do the Fourier transform of that. And that would mean that your momentum is spread out over a large area. It's over a large region. So you have more uncertainty about the momentum. And vice versa. If you know the momentum really, really well, then that would be like just a single wavelength sine wave, which means that you don't know where the position is. So that's the idea behind the uncertainty principle. It's really about Fourier transforms. From Tyran to Fruin, Tyrant of Ruin with the $5. Could the universe be a toroidal brane? Also, what are your thoughts on Turok's cyclical ekpyrotic universe theories? Could the universe be a toroidal brane? It could be. This is an idea that some people have had, that the universe is something like it's spatially flat, but it is still compact. This would mean that it's toroidal, essentially. I don't find this so plausible, if only because it would mean that there's an extra length scale involved, which just makes the whole model more complicated. And so Occam's razor would kind of imply that we should take the simplest model, which would just be an infinite model, if we assume that the universe is spatially flat, which it looks like it is. Now, as far as Turok's cyclical and ekpyrotic universe, I think that the idea is plausible. I don't know if the actual formulation that Turok has proposed is correct, if that makes sense. And from Dingo with the $5, do you think qualia presents a problem for scientific naturalism? Maybe not though. Depends on what qualia ends up being. And from Genderbender with the $2, if energy is just a number, what is ATP? ATP is a chemical. Right? If every element is different number of parts, could you change atoms' elements by adding parts? Yeah, this is how we do fusion. Also, with regard to energy, when you guys say energy isn't real, you mean the number assigned to the quantity, but the photon carrying momentum has a property that it transfers, we term energy. Look, so the point is that, so you could say that energy is real other properties are real. Like, is temperature real? Is temperature like a thing? Well, the property is certainly real. There is a property that we call temperature that we can talk about. We can meaningfully talk about this thing. But it's just like describing like a physical way that a thing is. It's not like a thing in itself. Similarly, energy is a property of a thing. It's not a thing in itself, if that makes sense. So it doesn't make sense to say that energy exists or that things are made of energy. Energy is a property of things. Now, if you think that properties are real, then you could say that energy is real and the same way that temperature is real. I'm upset that my textbook Physical Chemistry Elements doesn't go into the Fourier analysis aspects of quantum mechanics. Should I read the thermodynamic structure and change text? You know these? I don't know that book, no. But most quantum mechanics books, maybe not the very, very intro ones, but the most quantum mechanics textbooks are going to do this Fourier decomposition explanation. Do you think the timeless space outside of our universe could spawn more universes with different constants? Well, I wouldn't say it's outside of our universe. It's just like a different part of our universe, but it's possible, yeah. Do you think geometry is a piece of the puzzle for bridging quantum physics and general relativity? Absolutely, I think it is. In fact, I haven't mentioned this, and I haven't started writing it, but I do finally have an idea for a book that I want to write, which is going to be about geometry. That's I don't want to spoil too much of it, but you know, I haven't started writing it. I don't even have a title. But like I have this idea working around in the back of my head, and it's the kind of thing that, you know, maybe over the next few years, it's something that I'm interested in doing. Writing like kind of a pop sci-ish book about geometry. Do you have any book recommendations on quantum physics for beginners? Well, okay, the honest answer is David Griffith's Introduction to Quantum Mechanics. Like that's what the genuine answer is. However, it's hard to say that this is for beginners, right? It's for beginners, assuming you know calculus, assuming you know linear algebra, assuming you know some differential equations, and assuming you know classical mechanics. Has someone asked you about the Poynting vector? I'm a steady state DC circuit. No, in a steady state DC circuit, does energy really flow through the air to the load instead of through the wires? In a sense, it sort of does. So it also flows through the wires. The electric field flows through the wires, but not just through the wires. From J. Kalam S2 with the $5. Why are there exactly 3 generations of particles, electron, muon, tau? It's because of the Trinity. It's because the Trinity is true. No, I'm kidding. This is a question that we don't know the answer to. It's just not like, you know, it seems like there are just 3 generations of particles. For example, the leptons and the quarks. There's also 3 generations of quarks, but we just don't know. There could be more. From Ashley and the Cosmos with the $20. Placing my pre-order in. Look, this is just something that I've just started thinking about. I haven't sat down and I haven't written a single word yet. From Genderbender with the $5, perhaps I should have asked, how do we as physicists think about energy capture by biological organisms through breaking ATP into ADP? Well, look, I don't know anything about biology, so I couldn't explain that to you. But roughly, all I'm saying is that energy is a bookkeeping device for certain kinds of ways that systems can be. And so when we talk about one chemical bumping into another chemical, or one chemical undergoing a chemical reaction, we can keep track of a property of that chemical through the chemical reaction by looking at a certain, you know, it's basically a numerical combination, or rather an algebraic combination of other properties, and that algebraic combination happens to be conserved. But like, so you should think of it as, like, you can think of it as energy capture, but energy isn't a thing in itself. The thing is that what's happening is that the body or the organism or whatever is somehow undergoing some sort of chemical reaction or whatever, such that it is in a different configuration that's useful to do some things. And from Chaotic Life with the 2 Canuck bucks, can you explain gauge theory, classical versus quantum? So classical gauge theory is essentially just what happens, and it's actually a fairly complicated idea. Electromagnetism would be the simplest example of a classical gauge theory, but the idea is that you can have a what level do I want to explain this at? Okay, so I'll explain it this way. A gauge theory at the classical level is just a description of a kind of force. Now, in real life, there are no classical gauge theories except electromagnetism, but you could, in principle, like have a universe with a classical gauge theory. It's some kind of force, and the underlying mathematical object that is kind of fundamental to describe that force, like the gauge potential, if you will, or the gauge one form, has a transformation rule. A transformation rule that doesn't change that doesn't actually change the forces that it provides, but it just changes the mathematical description. And so that transformation rule is called the gauge symmetry. You're allowed to change it in a certain way without changing the actual forces that you observe. Now, this happens to be a really, really good way of talking about quantum fields, of talking about the forces that govern our world. And so the point is that just like how you can turn electromagnetism into a quantum field theory by essentially quantizing the gauge field, you can do the same thing with other quantum forces or with other classical gauge forces, and you can turn them into quantum field theories as well. And when you do that, you end up with the strong nuclear force, which is a gauge field theory, or it's a gauge theory. It's a quantum gauge theory. And from Tyrant of Ruin with the $5, if the rules for everything exist at a smaller scale, where is the information for how the universe works, e.g. cells, DNA, matter, particles, atoms, atoms, particles? I think that you're anthropomorphizing or perhaps thinking about the world in a way that I don't fundamentally agree with. I don't think that there is some information that's at the bottom. I don't think that like the rules exist at all. I think that the world is a certain way, and we write down formulas that describe the way the world is. From Garain with the $5, what would the universe look like had the muon been stable? Runaway fusion everywhere? It would be an interesting world, because if that's the case, then like its mass would have to be less than that of the electron, or at least equal to that of the electron, and that would be weird. I don't know. It's a good question. I'd have to think about it. If the muon were stable, or the weak nuclear force couldn't exist, but then there would be no reason to think that muons exist at all. And from Jinx Seed with the £5, what theory of time, A, B, or C, do you think is best supported by current evidence? What evidence would that be? I would say it's B, and it's just relativity. Relativity gives us evidence to support B. All right, sorry, I'm way behind. Let's answer some more questions. Is it generally possible that evolution has exploited electromagnetic fields for biological purposes? Well, yeah, I suppose. Yeah, I mean, like, all of chemistry is electromagnetism at the base. God, my nose is so itchy. The worst. So if humans are the highest form of intelligence, we're so smart, why can't we fix the world? Well, who says we're the highest form of intelligence? The world works the way it works because it works that way. No, it's not circular. What I'm saying is that things have certain dispositions. It's not that there's like some underlying math that tells the things how to work. Rules don't have causal power. Things behave certain ways, and then we describe the way it works. I don't think that there's some underlying rules. I think that things have dispositions. Currently second year in an astrophysics undergrad. How do I make sure I'm smart enough for a PhD? I don't know what that question, I don't know what you're asking me to answer regarding that, or what you're asking me to tell you with regards to that question. How do you make sure that you're smart enough? I mean, like, if you're doing well, then you're probably smart enough, whatever that means, for grad school. Would it be possible to create a state of matter beyond plasma? Well, sure, if by plasma you just mean ionized atoms. Sure, because there's quark gluon plasmas, which are not just ionized atoms. B is block time, right? Yeah, that's the idea. How would you respond to the question of dark matter being simply interference patterns of gravitational waves traveling through space-time? It wouldn't be enough. There's not enough gravitational waves to account for all of the dark matter. And from Dastan Jolborovsov with the $1. Thank you for the donation, bud. Is the universe fine-tuned? I don't know. I don't think that we can be certain about that. How do we know pi is irrational? There are proofs of it. I can't think of any off the top of my head. I'd have to think about it some more. But there are ways that you can mathematically prove this. And if you just Google proof that pi is irrational, you'll find some. So there's no y to the dispositions? It's possible that there's no y, yeah. Why are you a physicist at this age of AI? Any progress in the frontier, like what we are hearing in Where are you, physicists of this age of AI? Any progress in the frontier? No. The kinds of things that you're seeing in mathematics are not happening in physics, at least not yet. What are some things you do differently than most people in your everyday life based on your understanding of physics that most people don't? Probably nothing. Were you a child prodigy in math? Did your parents teach you math during your brain early formative years from 0 to 4? I don't know. I was definitely... child prodigy is probably too strong. I was definitely like good at math as a kid. Like my brother taught me long division when I was like 4 or not. No, I think I was probably 6 maybe. But like that's not prodigy level, right? Let's say advanced, not prodigy. Does a perfect circle actually exist? In a sense, sort of. But it depends on what you mean by like actually exist. Do you mean like can you draw one, or do you mean like is there a thing that's like perfectly circular? Because like as far as we can tell, like an electron is like a perfect sphere. Like the monopole, not the monopole. Like the dipole charge distribution of an electron is 0 as far as we can tell. Why do particles decay at the time they do? Why do they have the half-life that they do? At that moment of the decay, what in the particle changes to cause the decay? So the first question doesn't have an answer. As far as we can tell, there's no reason why particles decay when they do. However, the reason why they have the half-lives they do, that's a probabilistic thing, and that we can compute that from quantum mechanics. We can just calculate what the decay life or what the decay rate is, which implies a half-life for any unstable particle that's, you know, like a muon. You can compute this using quantum field theory. Can you explain how temperature can be negative? Yes, I can, and I've made a video about this, but the short end of the explanation is something like temperature is a measure of how quickly the entropy changes as you add energy. So higher temperature things are things that have entropy increase, but increase slowly as you add energy. Low temperature things, but above 0, are things that have the entropy increase quickly as you add energy. So you can imagine that there are systems that have their energy that have their entropy decrease as you add energy. This would be the case for any finite state quantum system. For example, if you get the system sufficiently energetic enough, then as you add more energy, the system will decrease in entropy because more and more pieces of that system will end up in the high energy state, and so you'll have more overlap, and so your entropy will decrease. This is what negative temperature means. If light has no mass, why does it have such a heavy workload? I want to do a physics PhD, but my grades are mid-tier. Is there any advice for how to improve my application, how to contact and separate myself to an advisor? That I don't know. So, I mean, you could always take the physics GRE if you haven't already and study really, really hard and do really, really well. That would definitely distinguish you from your competitors. Also, research experience could help. Population inversion, exactly. Sorry, I have to jump down to the bottom. Why is Planck time the smallest unit of time? How we know it's the smallest unit of time? We don't know that it's the smallest unit of time. What we do know, or what we have perhaps good reason to think, is that it's perhaps the smallest unit of time that we can measure, because doing so would require, or measuring a smaller unit of time would require sufficient energy that it would create a black hole, and it would kind of obscure whatever we were trying to measure. What was your GPA when applying to PhD? I had a 4.0. If a lump of uranium has half-life X, does all of the uranium on Earth treat the planet as a lump X? How does the uranium lump know that it's separate from other lumps? So every lump of uranium has the same half-life. And after half of it's decayed away, it's still the same half-life. Have you witnessed sexism in your field? Yes. Yes, I have. From Lost and Found with the 250 euros, best response to the fine-tuning argument for God. Yeah, I think that we probably have good reason to think that our understanding of fundamental constants is not fundamental. And so it just doesn't look like we have sufficient evidence to, you know, make the claim that the universe is indeed fine-tuned. How would you go about looking for research experience? Emailing professors that you've spoken with or that you've taken classes with. isn't the wave function just a mathematical tool like virtual particles? It's not. If not, what's the difference? So the point is the mathematical tool is in some sense supposed to describe something. I take it that the mathematical tool of the wave function describes some physical thing, and we just call the physical thing the wave function because we don't have a different name for it. Whereas virtual particles, we know what the thing it is they are describing. Virtual particles are essentially Fourier mode decompositions, or Fourier modes of a quantum field. And the quantum field is the thing that it's describing. We're just the virtual particles just allow you to describe it in a way that's kind of broken up into chunks. From John Wesley with the $2, how can I get you to debunk my model? Generally, this is a paid thing. If you want me to debunk, if you want me to like read through some stuff that you wrote, this is a paid thing, and it's not cheap because I don't do it. It's not really a thing that you'd have to really make it worth my while if you want me to do it. Yeah, last time somebody wanted me to spend 4 hours on something, they paid me $800 for it. That's what a flat earther asked me to watch a 4-hour documentary and paid me $800 for it. So, from Bacon and Bush with the $5, I'm only here shortly and without sound on, so just saying hello. Wish I could hear what's being said, but I'll watch the replay later. Fair enough. Hello to you, Bacon and Bush. Always good to see you. Gotta hydrate a little bit. From Rob with the $2 on Cash App, just send in thanks for asking to and ask a physicist. Well, I appreciate that. That documentary was just shit. Yeah, it was. You have to pay tuition fee for your education. I mean, as an undergraduate, sure. I was fortunate enough that, you know, between my between the scholarships that I had and the college fund that my parents saved up for me as a kid, I didn't come away from undergraduate with debt. And then for the master's and PhD program, they don't charge you for that. What's stopping us from making solar sails? There's some engineering limits. I mean, in principle, we probably could do it today, but it's hard. Like, you need really, really lightweight stuff. And so, like, it's just not super practical at the moment, although it perhaps is the kind of thing that we would want to build in the near future. From CSCRO with the $5, just send in $5. I appreciate that. Are you accepting guests? I will in about 30 minutes. Does the decay time half-life change when in a gravitational field or accelerating in accordance with general theory of relativity? Yes, it does. Do we have any evidence the fundamental constants of the universe could have been any other values than the values that they have? If not, fine-tuning is gibberish. There is no relevant probability density function. Yeah, that is the first objection that anybody should give to the fine-tuning argument. Have I ever heard of lambda calculus? Yeah, it's a computer science thing, right? If space is curved by gravity, who taught it geometry? Who taught it geometry? This is not something that... Space isn't sentient. Have you had to unlearn some of the things you were taught? Not really, no. Well, okay, maybe a while ago, but like it's been a while since I've had to do that. Does growing block universe work with relativity? Not really, because somebody else's future should exist while somebody else's present should exist even if it's your future. Are you still in academia? Sort of. Is there a limit to how large a black hole can grow? Would gravity still win with no matter how big the black hole gets? There's not a physical limit as far as we can tell, but there might be a practical limit in that, like, it takes a certain amount of time. Black holes can only grow at a certain rate as things fall in, because things can only fall in at a certain rate. And so there's a practical limit that, you know, black holes have only been able to form for the last 13.8 billion years or so. If energy isn't real, how can it cause the warping of spacetime? It's the stuff that causes the warping of spacetime. And the property of the stuff that's related to the property of spacetime being curved is the energy. Can't find your Cash App? It should be, if you go to my website, I'll show you my website, because this I may as well tell you about my website. More people should visit because it's a cool website and it shows off the kinds of things that I do. Yeah, if you go to my website, which is here, it's just blitz.phd, the URL. Pretty cool URL. Oops. Blitz.phd. If you go to my website, And you scroll down, and then you go over to the side, there will be some links. Those links where it says support me. There's Cash App, there's Venmo, there's Buy Me a Coffee, there's Patreon. You know, all the usual suspects, all the usual ways. So if you want to support me, that's one way to do it. Those ways are going to send more of it my way than like a super chat will on YouTube. But of course, I appreciate any and all support. What's the latest on dark energy? Still up in the air, as far as I'm concerned. Jumping down to the bottom. Why is it so important to teach Newtonian mechanics? Lagrange is so much easier. Newtonian mechanics is probably more intuitive. It's probably like closer to what people have in mind when they're thinking about how things work at like an intuitive kind of lay level, and so that's a good starting point. Also, historically, it came first. When it comes to math, do you always feel like we discovered it, or was it always there existing? I feel like we invented it. Do you think physics and philosophy are interconnected? Insofar as physics can lead you in the right direction for your philosophy, I think that that's true. Do you think, I already answered that. Which first and second year classes are the most important later? It's hard to say which is most important. I mean, like your intro physics class, the intro physics classes, which there should be like 2 or 3. These are going to be the things like electromagnetism and mechanics and, you know, waves, all of these things, and thermodynamics. These are classes that are going to be super, super important, but also so will your calculus classes. What was the moment you become a physicist rather than a physics student? When you start writing papers. If entropy always increases, why does my room occasionally get cleaner? Exactly. See? How do you feel about CQM mass models? I'm not familiar with it. All right, I have to blow my nose because my nose is so itchy. Sorry about that. Give me 2 seconds. Okay, I think I'm okay. You ever blow your nose so hard that your eyes start watering? I'm okay. Is Young and Friedman University Physics textbook a good physics textbook? It's the one I learned out of, and it's the one I've taught out of, so I actually think it's quite good. Won't black holes should always increase in size as if antimatter forms and falls into a black hole, reducing energy one another? Antimatter and matter pair form in which it's not that antimatter falls in reducing energy. It's that, and this isn't even quite right. It's not even a perfect analogy, but the idea is that when a particle-antiparticle pair appears at the event horizon, one of them will be inside and one of them will be outside, and by virtue of being inside of the event horizon, it has negative energy. Earlier this year, scientists created a mini-universe and seemingly demonstrated that time is eternally derived from a universe's entropy. Can you please discuss this a bit? I actually think I made a video about this a while ago. I know what you're talking about. They didn't show that time is internally derived from the universe's entropy. They just showed that that's a possible explanation for time. And so all this is saying is that you can have high entropy states in a superposition of low entropy states, and you can use the trends, or you can use the relation between, and you can use the, like, imagine that you have a static system that has a superposition of high entropy and low entropy. Well, then it turns out that the low entropy state can be reasonably described as the past of the high entropy state in like an internally consistent way. If you do want to see more about this, though, you should go watch the video. I think it's in my quantum field theory. Might be in my quantum gravity playlist, but it should maybe my quantum. Yeah, it should be in my quantum gravity playlist. I also have a video on the Page-Wooters mechanism, which is the kind of thing that they were testing. Are you reviewing anything interesting right now? If by reviewing you mean any papers, no. I turned down a paper to review to referee fairly recently because I'm really busy right now. Joe Schmidt just dropped his 7-hour-long video, and he includes fine-tuning as evidence for theism. I'd like to see your response to that section of the video. I don't really do the whole response to YouTube video thing. It's just not something I've done before, or not something I've done really. But I suspect that it's probably going to be more of a philosopher's understanding than a physicist's understanding. Does time slowing down for an object falling towards a black hole mean its energy decreases from an outside observer's perspective? Not necessarily, but its I mean, the thing is in that system, its energy is a little bit more tricky to define than what you would usually think. Its potential energy is indeed decreasing. Its kinetic energy is increasing. In some sense, you would want to say that its energy is, well, anyway, I'll just say not necessarily. The energy is not necessarily related to time, to the rate of time flowing. Can a perpetual motion machine exist in a vacuum-sealed container? No. When the universe is near heat death and there are only photons left, can you explain what physicists think, if anything, will ever happen after that, or if it will just spread out forever? Well, so it's not clear that heat death will definitely happen, by the way. If heat death does happen, then that means that it will just spread out forever. That's what it means for it to be heat death. If heat death doesn't happen, then you could have some sort of transition that happens. You could have all sorts of other things. According to the latest Sean Carroll podcast, black holes have limited angular momentum beyond which we don't have a theory. Can you explain why this limit is so low? It's not really low. The limit of the angular momentum for a black hole is precisely the limit where if a black hole was an object, like if it was just like a solid object that was rotating, the equator relative to the axis of rotation would be rotating at the speed of light. So it's not a low angular momentum. I don't know why Sean Carroll would say that. But what is true is that we call these extremal black holes. And what happens when you have a black hole whose angular momentum is kind of at this maximum value is the event horizon disappears. And you have a naked singularity. Now, we have some reasons to think that naked singularities can't exist. If naked singularities do exist, then we kind of lose predictability in physics, and this is probably not the kind of thing that is physically allowed. But like some people have talked about like super extreme, or what are they called? Super extremal black holes, and have tried to make sense of them. Apologies. I think it would be cool if the universe went out in one big rip, but unfortunately probably painful. Well, we probably wouldn't be around. As a physicist, do you think what would happen if the economy enters a recession and academia starts cutting jobs left and right? Genuine fear of mine. Look, so the question is whether or not academia is particularly susceptible to recessions. And I'm just not sure if that's true. Like, if you go look at academic jobs in 2008, like, I'm actually curious. Like, in the Great Recession, I guess there were, so I guess at like the public school level, there definitely were cuts there. But I guess what happened for universities, because the thing is universities can't really fire tenured faculty. Like, that's just not really a thing that they can do legally. So instead, they just shifted the burden onto students. Now, what will happen is you'll see hiring freezes, and that would not be good. But yeah, I mean, the thing is cuts are the kind of thing that are quite rare. Now, they might cut non-tenured faculty. That would probably happen quite frequently. What do you think about Noether's theorem and how she proved energy isn't conserved? Can you elaborate more? Yep. So what Noether showed with one of her theorems is that for any time you have a conserved quantity, there must be a corresponding symmetry. Namely, if you want momentum conservation, which is motion through space, then you have to have a translation invariance, meaning that if you take your laws of physics here and then you shift everything over, then the laws of physics are the same. And similarly, if you want to have energy conservation, then you need to have time translation invariance, which means that in some sense, like, the underlying structure of the universe should be invariant whether you're now or 10 billion years ago. But what we know is that our universe is expanding, which means that it doesn't have this time translation invariance, and which means that our universe globally doesn't have energy conservation. What will I eat for lunch? Probably a sandwich. Do I eat lunch? Yes. So does that mean the speed of light being emitted from a body entering the event horizon moves more slowly as it's emitted? Sorry, like I said, I have a lot of questions. So from an observer's point of view, light that is traveling by them always moves at the speed of light. From a distant observer's point of view, the light might take longer to get to you than you would expect if, like, say the light was coming from near the event horizon being emitted outward. It might take longer to get to you than you might expect if you assume that space-time is flat. What's a textbook you highly recommend? Sean Carroll's Space-Time and Geometry. Angular momentum over mass squared was apparently lower in black holes compared to stars of the same mass. Yeah, that's plausible. But that's only because black holes are so much smaller. Like, they're so much more compact. But, like, this is kind of expected, right? If you have a supernova that goes, you know, if you have a star that goes supernova, it's going to lose angular momentum. Now, I guess the question is does it lose more angular momentum or more mass? And I guess the point is that it's going to lose more angular momentum relative to mass squared. But from Ren90Fig with the $10, do you think error analysis in basic physics courses is on average taught well? I think it okay, so I can't say for it's generally taught in lab classes. It's not taught in the actual lectures. And so could there be more focus on error analysis? Yeah, probably. Is space-time a 2D surface? It can't be, right? No, it's space-time is a four-dimensional manifold. It's a four-dimensional thing. Why do conjugate points imply geodesic incompleteness? They don't. Maybe they do in Lorentzian spacetimes, but in Riemannian spaces, they absolutely don't. On a two-dimensional sphere, the surface of a sphere, think like the surface of the Earth, there are plenty of conjugate points. But the surface of a sphere is geodesically complete. In fact, every point is the conjugate to some other point on the sphere. Now, if you mean time-like conjugate point, or time-like separated conjugate points, maybe. I'd have to think about that a little bit more. So what does sustains the energy of the universe if the energy is not being conserved? Energy is not a thing that needs to be sustained. Not like a substance, if you will. With regard to energy, when you guys say energy isn't real, you mean the number assigned to the quantity, but the photon carrying momentum has a property in that it transfers. We term energy. So when I say that energy isn't real, what I mean is that it's not a substance on its own. It's not a thing that makes up other things. It's certainly a property in the same way that temperature, that momentum, all of these other things are properties of things. Now the question is do properties exist, or are properties merely like labels? That's a deeper philosophical question. But what I mean to say is that it's not like a thing. It's not like an object, a thing that exists on its own. So it would be wrong to say that like a particle is made of energy. Can the Higgs boson be made of more components? It could be. These are ideas called composite Higgs theories, composite Higgs models. It's not clear, like it looks like the evidence that we have is consistent with a fundamental Higgs, but people are still looking to try to see if maybe there's a way that, you know, the Higgs is composite in some way. If you can ascribe an age to the universe, therefore it's not eternal. Well, not necessarily. So when we say the universe is 13.8 billion years old, what we mean is that the universe as we know it is that old. Now, if the universe goes through cycles, this would just be the amount of time since the latest cycle. If the universe, you know, collapses and then re-expands only once, then this would just be the amount of time it's been since the re-expansion, even if it was collapsing forever prior to that. So no, it doesn't necessarily imply that. Do you believe that Brumhilde and Draugr are the true Viking hip-hop king and queen? Yes, I do. They are indeed the Viking hip-hop king and queen. I don't know why I can't talk today. Where did the energy that initiated the Big Bang come from? It's not clear that that's a question with a well-defined answer. What would you say is the hardest physics and math class course you have ever taken, and did it ever get easier? Did you study or learn in any specific way to help you? So the only class that I... okay, so when I was in undergrad, the hardest class I took was point set topology, and I tried to take this as a freshman, and that was a mistake, so I ended up withdrawing from the class. The hardest math class that I finished, which, you know, I only withdrew from one class. The hardest math class that I finished was a grad level abstract algebra class. And it was just really hard. I ended up doing very, very well in the class. I didn't like improve. I don't know if I improved at it. Like, I think that I still did better than almost everybody else in the class from the get-go, but I didn't do well, right? Like, you know, average exam, like I remember the midterm exam, I think I got like a 55% on it, but apparently that was like in the upper decile or something like that for the class. So, you know, hard to say. As far as physics, the hardest physics class I took was statistical mechanics. And the reason why it was hard was because, well, I mean, maybe it's just a hard topic, but I feel like nobody teaches it well. And the professor that I had in particular didn't teach it well. So it was really hard to understand what was being, like what the intuition was. So the gluon is analogous to the photon in QCD like in QED. The photon is real, but in the context of QED and charge interactions, the photon is a virtual particle. Is this analogy right? So the photon is real in the sense that you can have free photons. There are free photon, like that's a valid solution to the field equations, right? Free photons can exist. And so these would be real. Free gluons cannot exist. So you'll never end up with real gluons. But the gluon field exists. The reason why you can't end up with real gluons is because the strong force is strongly coupling. And so you will always have some sort of strong coupling dynamic. Yes, in QED and charge interaction, the photon is a virtual particle. Yes, it is. Because what's really happening is just that you have electromagnetic fields that are mediating these forces. It's the fields that are fundamental, not the particles. Does a mass following warped shape of spacetime cause or effect? Wait, does a mass following warped shape of spacetime a cause or an effect of gravity? It's an effect. Or you could call it gravity itself, actually. Would you say gravity dimples the fabric of spacetime? Why or why not? It's a little bit more complicated than that, is the reality. We haven't mathematically proven that you can't have free gluons yet. Okay, well, yeah, but we can. Like, we've never seen them. Are you friends with any famous physicists or scientists? Friends? No, but I did take a selfie with Penrose. Is Noether's theorem only approximately true for the universe since it's not times translationally symmetric near the Big Bang? No, Noether's theorem is like literally true. It's a theorem, right? But the point is that Noether's theorem says that energy is not conserved for a universe. Is space-time fundamental or emergent? I'm currently leaning towards emergent, but you know, we don't have evidence to support that. Show the selfie? Okay, let me pull up the selfie. Albums. Cambridge. I met him at a conference in Cambridge. Not a great picture because, you know, of this glare, but here's the selfie. Also, it's a horrible smile on my part. Like, I didn't have a chance to take another one because he was kind of grumpy at me. He wasn't really happy about me asking for a selfie, but he obliged, which I appreciated. Is it true that energy cannot be destroyed but only changed from one form to another? That sounds cool. No, that's not true. That's the kind of thing that you learn in like a chemistry class, and it's like true enough on Earth, but it's not really true at the global scale, the cosmic scale, if you will. What are the evidence against neutrinos being dark matter? Explain, please. Yeah, so the first thing is that the neutrinos that we're familiar with, the light neutrinos, the electron neutrino, the muon neutrino, and the tau neutrino, these are too light to be dark matter. We know that dark matter has to be cold and has to be kind of slow. But because neutrinos are far too light, they would end up being hot dark matter. Now, what is true is that there could be sterile neutrinos that are dark matter, and these would be heavy, and so they could be the cold dark matter in the dark matter model. But the neutrinos that we know exist, they can't be really. Okay. Person's been asking for advice. Ms. Ollie with the 10 pounds, what do you think of other interpretations of GR like dynamical relativity? Do you think space and time are absolute and space is a superfluid and does not curve into time? I'm not familiar with this idea that space is a superfluid, nor am I familiar with dynamical relativity. If you're talking about like the ADM interpretation, then like that's just an interpretation, but that doesn't really tell you anything about like I take the ADM model to be, it's not really an interpretation, it's more, or the ADM formulation I should say, it's closer to like a mathematical way of doing the four-dimensional space-time stuff. What does working as an astrophysicist look like, at least the ways you're familiar with? Well, I'm not an astrophysicist, so I don't know. Hey, I'm a physics major. It's the second most unemployed major after anthropology, of course, and I'm scared to not find a job. Advice: if you're worried about not finding a job, then go to grad school. I kid a little bit, but seriously, like it is a highly unemployed major. I don't know why. I don't really have a good explanation for this, but you can always go to grad school. Do you think Penrose's cyclic cosmological model is likely based on the present data? I'm not so convinced. What do you think about the theory of particles act differently when observed, and how do they know they are? They don't act differently when they're observed. They act differently when you interact with them. That's because you're interacting with them. They don't know anything, you're just interacting with them. Meant physicist, yeah, so, what was the question? What does a day look like for a physicist? Yeah, I don't actually remember what the question was. Would a hypothetical observer moving at higher speed than c in our universe have 3 dimensions of time and 1 dimension of position? No. Our community just teared up? Let's go. Hell yeah. Why do you believe in the existence of expanding space? You can't observe it? I mean, you can observe its effects. You absolutely can. What do you think redshift is? Why do you think that we observe baryon acoustic oscillations of smaller and smaller size as we look further and further back in time? Further and further away? Like, this is all evidence for an expanding universe. Is it common for physics majors to go back to school for engineering? I don't think it's common to go back to school, no. Now, do you learn on the job? Probably quite frequently. Is degeneracy pressure one of the 4 fundamental forces, or is it purely a different effect? It's a different effect. It's not a force. I thought Neil said when you look at it, it moves differently. Well, if Neil said that, he was wrong. energy can be destroyed, then the universe can be made to disappear into a nothing before and after it existed. I mean, I guess, but I don't think that, like, you still need a mechanism to explain that. Why doesn't visible light have the property of Compton scattering? Compton scattering is when... Isn't Compton scattering light off of electrons? There's like all these different types of scattering. There's my scattering, there's Compton scattering. So Compton scattering is... Where's the diagram? Yeah, it's just, it does. It absolutely does. Photons can scatter, like photons of all wavelengths can scatter off of electrons. I mean, it just, like, it just does. Do you think the universe is eternal? I don't know. Progressive atheists equals death of Western civilization. That's crazy because, like, progressive atheists were the kinds of people that were the same kinds of people that, like, led to the development of Western civilization. Like, who do you think the Enlightenment thinkers were? These were, like, people who were closer to atheism than they were to Christianity. And they were progressive. From Ms. Ollie with the 5 pounds, could dark matter just be large clumps of heavier quarks? Since they are predicted to be stable in very large clumps? No, because you can see those things. Quarks are charged. The tension that energy is contingent upon a non-contingent prime constraint. Okay, I don't know what that means. But the point is like, photons and electrons can scatter. There's no like energy limit, right? Why are so many of my engineering professors all studying gravitational waves? Well, they're probably physicists who are teaching engineering courses. This is quite common. And if they're studying gravitational waves, it's because it's an interesting problem. Thoughts on holographic principle? So I'm not sure if it indicates anything about reality or more about like mathematical descriptions of reality, but I had a thought the other day that actually it could just be the idea of the holographic principle could perhaps be a consequence of the possibility or of the idea that you can have equally good emergent space-times that have different numbers of dimensions that emerge from the same underlying quantum system. Enlightenment thinkers were Christian Protestants, buddy boy. I'm sorry, what about Thomas Jefferson? There was nothing about him being a Protestant. He was like a deist at best. How does relativity and quantum physics work together, like how space-time can bend with probability cloud? We don't know. Sub only? In 2 minutes, sub only, yeah. Everybody will be able to watch. He was a Protestant. Yeah, have you read the Thomas Jefferson Bible? He took out all the Jesus. Why did he take... The Jefferson Bible is famous for taking out the Jesus. What kind of Christian takes out the Jesus from the Bible? Or takes out the miraculous bits anyway about Jesus. I mean, he didn't literally take out Jesus, but... how does dark matter and dark energy pass for each other? They're not necessarily related at all. From Rust and Peace with the 5 pounds, how is Hawking radiation entangled to the black hole when it is emitted from far away and be similar to Unruh radiation? So it's not clear that it's emitted far away. The thing is Hawking radiation is you're only able to talk about Hawking radiation when you're infinitely far away. So it's not really, there's not really a straightforward way to say that like the Hawking radiation is actually emitted from far away from the event horizon. The Hawking radiation is the kind of thing that if you look like initially far away and finally far away, you'll notice that there's radiation coming out in the final case. Now it is similar to Unruh radiation in that, you expect, so if you hang out near the surface of a black hole, you have to apply constant acceleration. If you constantly accelerate, you see a thermal bath of radiation. And so that's the kind of thing, like that's why there's a relationship there. At least that's the intuition that I have. Now, it's not really clear to me how Hawking radiation is entangled to the black hole, because we don't actually know what's going on with the degrees of freedom inside the black hole. But seemingly it must be entangled with the black hole if there's going to be something like information being conserved. So dark matter has to be slow and heavy. Is that what I'm getting from you? And why so? Yes, it does, because it has the properties of like a dust that's slow and heavy. It doesn't really behave relativistically is the issue. Do you think religion goes against physics, or is it possible to be religious and a physicist? Yeah, you can be religious and a physicist. There are several. I don't understand your answer on why visible light doesn't have the property of Compton scattering. Compton scattering is a property of X-rays, right? Compton scattering is just any scattering of electrons and photons. That's all. That's all Compton scattering is. So like, it can happen with any wavelength. It's just, and in fact, we can probably go look up the probability of the scattering event. Is somebody not giving me the probability amplitude? It probably scales inversely with, or probably scales with like the energy of the photon or something. So that's probably why you don't see it often. I mean, how does dark matter and dark energy pass through each other? Well, it's not even clear that this is the kind of thing that they do pass through each other. But like, look, photons can pass through matter. Re-upping my question on what WTF mass is and why people think of it as stuff when you have tons and tons of particles with no mass. So people conflate mass and matter. Matter is stuff, right? But mass isn't necessarily matter. Mass is just, you can think of it as so energy is a property of systems. Mass is the kind of the subset of that property, or it's like the amount of that property that the thing has. It's like how, like, you know, it's the energy property that the thing has when it's at rest. That's all mass is. All right, so it is time. We are going to make it member only, subscriber only, all of that, blah, 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 blah. Everybody will be welcome to continue watching. However, members, people who support me with $5 a month, will be the only people who are going to be able to send messages. However, if you don't do that and you still have a burning question, then what you can do is you can join up and you can join the guest box on TikTok or on Discord, and I will still happily take your question there. So give me just 1 sec so I can change the settings, and then we will be good to go. And the reason I do this, by the way, is to incentivize people to, you know, support me for $5 a month, because then you get your questions answered. But yes, we will be doing call-ins in just a moment. You know, it's a good way to encourage people to, it's a good incentive, I should say. 1 sec. Almost done. Oops. Okay. We should be good. We should be in members only mode. And you know, regardless of where you are, if you're on Twitch, if you're on TikTok, if you're on YouTube, this will work everywhere. It's going to be $5 a month everywhere. Right. So let's answer some questions. Then we'll bring up some live guests. So we have. What if all of any element is connected? I don't know what that means. Symmetry is God? I don't know what that means either. Scripted and controlled debates, classic atheists. We're not doing debates today. This isn't a debate, so I think you're in the wrong place. What do they mean when they say the Higgs field doesn't give the full mass of the protons and its energy that does give the rest of the mass? Please expatiate. Yes, so the idea is that if you add up the sum total of the rest masses of the quarks that make up the proton, you don't get enough mass. The point is that the protons are moving. You can kind of think of it this way. This isn't an exact picture, but you can think of it this way. The quarks inside a proton are moving around really fast, and they have really, really high potential energy as well. And so it's those two things, you know, those two things contribute to the mass, because that energy is present whether or not the proton itself is moving. And the mass of a proton is just the energy that it has when it's stationary. I was incentivized. Good to see you, Mr. Lint. Appreciate it. From David Orbit Science, if I believe in information first ontology, emergent spacetime, and eternal inflation, would I be considered a believer in contingent universe or a necessary one? I think that depends on you. It's hard to say what you would be unless you tell me what your position is. I don't know why it doesn't tell me when somebody becomes a member. So if anybody was incentivized to become a member, whether on Twitch, on YouTube, on TikTok, I appreciate it, and thank you so much for being here. All right. Hey, this is the canonical guy. Can I come up? Wait, hold on. Why aren't I seeing the TikTok chats? Hey, this is the canonical guy. Can I come up? Yeah, in a minute. What does it mean when I'm just going to finish answering some questions and then I'll bring somebody up. What does it mean when a quantum theory is UV complete? What it means is that it doesn't run into problems as you as you examine the theory at higher and higher energies. Generally. These two oddities potentially related? One, causality. Causality being dependent on different observers' reference frames, and two, probability-based many worlds. No, they're not really related at all, at least as far as I can tell. Best part of being a member, spamming the lamp. True, that is true. You also get emojis if you become a member. You also get access to my debate notes, and you get access to a private Discord channel in the Discord server. So, you know, there's some perks. Obviously, you don't have to, but it's a good reason to, or it's a good way to support me, and it's a good way to get some perks if you like them. And from Ms. Ollie with the £5, how do you explain delayed choice quantum? You mean delayed choice quantum eraser experiments? How do the particles know they will be measured and interacted with in the future and collapse before? They don't. So what's happening is that in the Copenhagen interpretation, this is still easily explained. So particle hits the screen, collapses when it hits the screen. Depending on where it collapses to, that affects the probability of how you will measure the outcome later. So you will either measure it being in one way or in another way later. There's no retrocausality happening. Now, what can happen is that if you filter for getting one output measurement, then you'll only see the dots on the screen being a certain way. But that's because the dots on the screen collapsed, and that caused those to be the ones that caused the output on the other end. It's not the other way around. Lamp is love, lamp is life is the lamp a llama. The lamp is not a llama. I meant, like, what if all iron in the universe, for example, is physically connected somehow? And what if my grandma was a bicycle? Like, I mean, you know, you'd have to elaborate more so that I could see what the consequences would be. You answered my question during the regular phase. I'm just glad to be enjoying the gifter membership. Of course, thank you for being here. Thoughts on space going through a mereological phase transition in J1, J2 spin chains? You'd have to be a little bit more specific. J1, J2, like, do you just mean like standard like spin chain configurations, like in what are they called? Not spin glasses. It's like the grid where you have nearest neighbor interactions. Like, I'm not sure about space going through a mereological phase transition though. All right, let's bring up a guest to ask some questions. Let's bring up Patrick Starr. Patrick Starr, how's it going? Patrick, you there? Okay, Patrick Starr's not here. Let's bring up Cecil Fergelmeyer, who was next on the list. Cecil, how's it going? What questions you got for me?
Oh, Dr. Blitz, thanks for taking my call, buddy. Appreciate it.
Yeah, what physics questions you got for me?
Okay, I have a question about Arrhenius equation.
I don't know what that equation is.
Well, okay. Have you heard of Savante Arrhenius?
Nope.
Believe it or not, he's Greta Thunberg's distant relative. And he's the first one in 1896 to calculate the non-linear algorithm of CO2 in the atmosphere.
So I just typed in Arrhenius equation, and all I'm getting is it describes how the rate constant of a chemical reaction changes with temperature and activation energy. Is that what you're referring to?
Well, no, it's not.
Okay. So I don't know what you're referring to.
Well, the thing is, he was a chemist. Okay, so the Arrhenius equation refers to chemistry, but you have to look at his what he says about CO2.
Okay.
He's the one that said,
do you have a question for me, or is this just you want to tell me about something? Because this is a question and answer kind of live stream.
Well, it's a question because I want to understand.
Okay, what's the question?
I want to know. Okay, so help me understand if I'm understanding his equation properly.
I don't know anything about his equation, so I can't help you understand it.
Well, it'll just take you a minute or two to look it up.
The thing I'm finding doesn't seem like it's related to CO2 at all.
You have to type in Arrhenius prediction of warming based on CO2.
Okay, so you want me to answer a question about something that I've literally never heard of before?
Well, you said I was wrong about it last time I mentioned it. What I told you...
I don't think that you've ever mentioned the Arrhenius equation. Anyway, if you have a question about physics, I'm happy to answer it. It sounds like you have, at best, a question about chemistry.
No, it's not chemistry. It's CO2.
This guy was a chemist, was he not?
Yeah, but he's the one... All of our climate models are based on his equation that when he said that if you double CO2...
Okay, this is a debate. You want a debate here, Cecil. Today is not the time. All right, let's bring... Oh, Patrick Starr is back, and then we'll bring up a guest from Discord. Patrick Starr, welcome back. Patrick?
Hello.
Hey, Patrick, what questions you got for me?
Cool. First of all, just want to say I'm a big fan. I enjoy your content.
I appreciate that.
And so I had two questions.
Yeah, sure.
My first question is basically, what's your opinion on the reasoning behind the measurement problem? Essentially, do you subscribe by the Copenhagen interpretation, many worlds, or something else?
I'm a many worlds kind of guy. So I don't think that there is a measurement problem. I think that the wave function never collapses.
Does that extend to the way that like people think about the many worlds interpretation in like fictional media, where there's like an infinite number?
Almost certainly not.
Yeah. So what does okay. So what does the many worlds interpretation actually just mean in physics?
Depending on how deep you're willing to go with it, the many worlds interpretation is roughly this, and this is the one that I subscribe to, is that the universe is fundamentally described by a wave function, some kind of physical object that obeys the Schrodinger equation, say. And you can look at subsets, or like, what are they called? Kind of like regions of that wave function. And you can look at how they're related to other regions of that wave function. We would call that entanglement. And that wave function can be in a superposition of multiple states. And if it is in a superposition of multiple states, then we would say that that there are multiple worlds. And those worlds, that superposition of multiple states, they can't really talk to each other. That's basically it. And once you have that view, then it's not so far-fetched to say that, well, what's happening when you make a measurement is that you have two different pieces of the wave function that become entangled. And when they become entangled, or you have one piece of the wave function that's in a superposition that can be described as being in a superposition. And then when that part of the wave function interacts with another part of the wave function, it entangles the entire, or it becomes entangled, and it forces the entire wave function to become in a superposition itself. And so once you have a superposition, you have different worlds. Once the entire universal wave function is in a superposition, you have different worlds. That's the way that I think about it. It probably wasn't explained particularly well, but that's the way that I think about it. And in that case, there is no measurement problem. It's just that the superposition of the thing that you're measuring becomes the superposition of the wave function.
Right. So does that mean like superposition is all of those states existing at the same time? You know, with how Erwin Schrödinger made the thought experiment to try and say why it's like illogical, or not illogical, but just non-intuitive. But quantum mechanics, I'm assuming, is quite non-intuitive, at least compared to like macroscopic world.
Yeah.
Okay, cool. Just a few more. I don't know how much time I have allotted.
You're good. You have time for a few questions.
Okay. Just one the quick one was, you said something earlier about how the law that energy can't be created or destroyed only makes sense in like a small scale or in a chemistry class or something.
Yeah.
But that's not true in space. Are you talking about like mass energy conversion, Einstein, etc.?
No, it goes even deeper than that. So at a cosmic scale, our universe is expanding. And what that means, and you can prove this mathematically, is that there is no conserved quantity called energy that covers like the whole, like the energy of the whole universe. Just not a thing that exists. It's not a thing that can exist because the universe is not so-called time symmetric, meaning that the kind of the behavior of space-time is not the same now as it was a billion years ago. And one of the requirements to have an underlying conserved energy quantity is that you have that the underlying behavior of your space-time is the same across time.
Interesting. That's very interesting. I haven't heard that before.
Now, the reason why I say it
That's cool.
applies locally is because the universe, despite us saying the universe is expanding faster than light or whatever, the universe's expansion is actually very, very slow. And it requires an extremely large amount of area or extremely large amount of volume to have a measurable amount of expansion. And so on the Earth, there's no measurable expansion. It's sufficiently small. It's like orders of magnitude lower than anything that we could ever hope to measure. And so on Earth, we may as well treat the expansion of the universe as static, or the expansion of the universe as non-existent. And so then the energy conservation laws still go through. And similarly, you'll find that it's totally reasonable to talk about energy conservation in, say, a galaxy, because even galaxies are too small for this kind of failure to rear its ugly head. But it does happen at a global scale, the scale of the entire cosmos.
Okay, cool. That makes sense. And last thing I wanted to ask was, well, in my graduate physics and chemistry classes, I learned just like a little bit about the Heisenberg uncertainty principle, just like very basic. It's like you can't determine the position and momentum of like electron, for example, specifically, but I was never really explained like, I don't know why that is the case or any more elaboration. I heard one person say something about how position and momentum are Fourier transform values.
Yep.
Or something. Do you heard anything about that?
Yeah. In fact, I gave that explanation. I gave that explanation like half an hour ago when somebody asked the same question. But so roughly the idea. No, it's fine. It's fine. So the way that we talk about quantum mechanics is we talk about in terms of operators. So you have some sort of operator, you apply it to the quantum state, and if say the quantum state is an eigenstate of that operator, then out pops a value that tells you how much x the thing has. So if you have a quantum state that's in the position eigenstate, then you apply the position operator to the quantum state, then out pops the location of where the quantum state is. That's the result of applying this operator to the quantum state. And so position So position and momentum are both quantum operators, and in the position basis, so they're operators, and you have to choose a basis to write them down in the same way that, like, if you want to write down a linear transformation matrix, you first need a set of basis vectors. So in the position basis, the position operator is just multiplication by the position vector, but the momentum operator is a derivative. And so if you remember from your real analysis class or wherever you learned Fourier transforms, the derivative is in some sense the Fourier transform of multiplication by x. And so they are conjugates to each other. They're duals. And so this is all to say, physically, what this means is that, and the reason why Fourier, so let me back up. So the reason why Fourier transforms are relevant here and why it's not just like a math trick is because Fourier transforms are the kinds of things that let you learn about frequencies compared with time domains, and let you learn about wavelengths compared with spatial domains. And if we think of particles or quantum states as just being waves, then you can talk about the frequency of those waves, or you can talk about where those waves are. And it turns out that if you want to talk about, not frequency, I should say, the wavelength of those waves, if you want to talk about the wavelength of those waves, the way to do it is with a Fourier transform, so that you can then measure its wavelength, because that'll tell you information about its wavelength or that'll tell you about probabilities in the wavelength space. If you want to learn about a particle or about a particle's position, again, a particle is a wave, then you don't do the Fourier transform from the position basis, and that will tell you about the probability distribution of positions. But because they're dual to one another, if you localize the position, you spread out the wave, or you spread out the wavelength. Because the Fourier transform of a spike in position space is a very, very wide distribution in wavelength space and vice versa. And wavelength is intimately related with momentum, and so you get this duality that happens. In fact, the perhaps unsurprising thing, and I made a video about this a while ago, is that the Heisenberg uncertainty principle applies to classical waves. It just is a property of classical waves. It's not a quantum thing at all. Which is, perhaps unsurprising. Or perhaps surprising, rather.
Okay, that's cool.
Does that help at all? I kind of rambled for a bit, but...
Yeah, it helped explain some things. Obviously, well, at the very least, it will help me like have a look at this myself later, which is some of the points you brought up. But yeah,
let me show you something really quick. Maybe I can help. This is just a quick diagram, which maybe captures the idea. So if you want to talk about a particle being localized, it has to be like an isolated bump, right? But in order to create an isolated bump from a bunch of different sine waves, you have to add a bunch of different waves together. And each wave is going to correspond to a different momentum. So this particle, which is isolated in space, it's localized, has a small angular or a small position uncertainty. It has all of these different wavelengths as its components, and so you don't know what its momentum is. Its momentum is going to range from whatever the momentum is of this wave all the way up to the momentum of this wave. And the same is true in reverse. If you want to localize the wavelength, then you just get a single wave. Or if you want to localize the momentum, you just get a single wave, but now where's the particle? It could be spread out across this entire wave. So that's the idea. There's kind of like a way that you can Fourier decompose a wave like a particle wave function to get a whole bunch of different waves, or you can transform a wave function and you can get a whole bunch of different particles spread out across space. It's kind of another way of thinking about it.
Yeah, okay.
Hopefully that helps. I should have started with the diagram.
Yeah, it does. Dr. Blitz, thank you.
Of course. Take care. I definitely rambled for a bit there. I apologize, Patrick Starr. We do have some questions to answer, and then I'll bring up another guest. I am out of water. So sad. Okay, let's scroll down. Make sure I don't miss any. Always love your streams. What's your favorite debate topic? I love doing the flat earth debate. I just don't get flat earthers very often anymore. How well do GR and quantum theories about light work together? Does the strangeness of time at macro scales in GR cause problems for quantum physics describing photons? Not really, no. So once you fix the background spacetime, or you can go even further and you can just like let the average quantum results kind of cause spacetime curvature, there's not really any issues. The question is, how do you quantize GR at all? That's the thing that we don't know how to do. But you can use like kind of the average results from quantum mechanics to cause curvature of spacetime, and you don't run into any issues. This is called semi-classical gravity. From Music Makeshift with the question, did you ever research the Upanishads or in general just Christian books? I've read the Upanishads. I read them in college. Or I read it in college. Is there some physical reason or explanation for the Born rule? Why do we square the wave function to get the probability? Why not cube or some other function? This is not something that I'm sure that anybody really has an explanation for. As far as I know, there isn't a physical reason or physical explanation for it. Well, okay, so in the Bohmian interpretation, there is. You get a physical explanation because the squaring the wave function tells you where the unseen wave is. This is just kind of, well, okay, then I guess in that case it actually doesn't tell you. It kind of just assumes it. So yeah, as far as I know, there's not really a physical explanation for it. From Game Master Flash with the $10, as we delve more into physics, are we getting closer or further away from a hypothesis that unifies quantum and classical physics? Do they still call classical physics Newtonian? Classical physics is anything that's not quantum physics. So general relativity is considered classical physics. Classical physics isn't expected to be unified with quantum physics. Rather, we expect the classical physics to sort of emerge from quantum physics. So there should be some procedure where you kind of zoom out, or you coarse grain the quantum and you get classical out. From John with the $10, would you debate any of the well-known Christian or Muslim debaters like Jesus and whatnot, or the Orthodox Muslim? Since you like to host living debate, you like to host lives debating God's existence. Absolutely. In fact, I've offered a debate to Jesus and whatnot. He has left me on red. And I've never spoken with Orthodox Muslim, but I'd be happy to talk. Look, I'm open to debating whoever. unless they're like a known Nazi or something. Like, I'm happy to talk with whoever. And from Garain with the $10, in quantum mechanics, we only talk about wavelength. Waves also have amplitudes. What's the amplitude of a photon? The same for every photon, proportional to the wavelength, or is the amplitude only a macro scale thing? You can talk about the amplitude of a photon, but the thing is it's not like a distance. It's not like you can talk about the electromagnetic field from a single photon. That's the thing that you can do, and you can talk about like how strong the electromagnetic field gets. That's absolutely a thing. I don't know offhand what it is, but yeah, you can talk about it. And by the way, the reason that you can say this is because the energy of the electromagnetic field is very closely related to the magnitude of its, like kind of the amplitude of the electric component and the amplitude of the magnetic component. And because we know what the, because we know the relation between the electric and magnetic components of a propagating electromagnetic field, they're related by the like 1/c. And we know the energy of a photon, we can solve to find the amplitude of the electromagnetic or of the electric field. Interesting, thank you. I'd like to think that their description of Vishnu breathing in and out, describing the expanding and retracting universe, just a thought though. Lots of different ancient traditions have ideas that are similar to our cosmological models. It doesn't mean that they knew anything, it just means that these ideas are perhaps not so young. A while back I saw a video that there aren't unseen spatial dimensions beyond the known 3, because if there was any, there would be an overall perturbation. Did I get this right? Well, we don't know that there aren't any, just that they are smaller than we can currently probe. From Krehenge asks, Carol says that if you take the Schrodinger seriously, the many worlds pop out, but there are no variables for the worlds. Can you explain what he means? Yeah, so what he means is that if you apply the Schrodinger equation to every system, all the many worlds they are just the superposition of a quantum system describing the universe. That's all. And the Schrodinger equation just allows for superpositions to exist. And so the Schrodinger equation, and if you allow for internal interactions, you can get those superpositions to pop out. You can produce those superpositions. You can kind of propagate superpositions from small subsets to the entire thing quite easily using the Schrodinger equation. These are just using like interaction Hamiltonians. Then you do just end up with a universe that has that is a superposition of many different states, and those are the many worlds. Is the Higgs field a condensate that permeates all of the universe? Yes. I'm not sure I would call it a condensate, but it does permeate the entire universe. And from referential recurrence, if particles are a soliton of a field disturbance, so to speak, is it not just a property of a field as well? Is the distinction between particles are generally how we think of things? Yeah, particles are just properties of a field. They're not quite solitons, because solitons are like non-dispersive. But they are just, you can kind of think of them that way. They're propagating disturbances of a field. All right, let's bring up a guest from Discord. Let's bring up Darth Jar Jar. Darth Jar Jar, how's it going? You gotta unmute yourself. There you are.
It's going good.
Glad to hear it. What questions you got for me?
Big fan. Well, the question actually comes from something I heard you guys say on Unapologetic.
Sure.
And I'm a bit interested to ask. You might have already touched on it with the many worlds interpretation, but you guys seem to have said that the quantum mechanics seems to be deterministic and not probabilistic. From my understanding of just, again, pop sci, I'm not that deep into it. I don't get the equations or any of that. So I was just wondering, what would your take be on that? Is this more probabilistic, or? It
depends on your interpretation. So if you take the many worlds seriously, then it's entirely deterministic. There's no stochastic anything. If you take the Copenhagen interpretation seriously, then it is not entirely, but it has inbuilt randomness. And so it just depends on which interpretation you think is more likely.
Would there be any way to validate either of these over the other? Or is it purely just
in a sense, possibly, yeah. So the many worlds interpretation is kind of what's left over after you've eliminated all of the other possibilities, because it makes kind of the fewest assumptions, the fewest dynamical impositions on how quantum mechanics behave. So if you can rule out the other options, then all you're left with is many worlds. But you could, in principle, experimentally show that there is some stochastic phenomena by like watching it happen. If you could somehow watch the wave function collapse, then you'd be done.
Okay. And just to probe a little bit on the many worlds thing. I understand it isn't the sci-fi, you have infinite branching universes there, everything happens, and you just kind of explained it already. wouldn't it still be kind of probabilistic to see which world state you would be in within the superpositions of all these?
Well, you'd be in all of them.
There's no way to.
But the question is like there would be a you in all of them is the point, or all of the ones where you formed. There might be ones where you never formed at all, but all of the ones where you formed, you would be in all of them. The question is which one are you experiencing? I mean, well, in principle, you're experiencing all of them, so there's not really a question. Now you could say like, okay, so there is some like conscious experience that you're having, and you could say which world is that conscious experience found in. Now there is going to be that conscious experience found in every world, but each one will be associated with one world. And so the question is just, how do you know which one you're in? That's more about like not knowing where you are, not about some underlying uncertainty.
I think that makes sense.
Or underlying randomness, I should say, because there's no randomness, right? There's a you in all of them. It's just which one you don't know which one you don't know which of the yous is the one that's having this experience. And so you're just like temporarily confused until you go and you make a measurement, and then that tells you which one you're in.
Okay. I think that makes sense, but it's hard to put into language in a way we can understand. But I think I get it.
All right. Anything else?
No, I think that's about it. Sorry if it was not that
You're fine.
deep a question.
You don't have to apologize. Have a good one.
All right. Thank you very much.
Oops. I just want to double check that I didn't miss any cash apps. All right, so then let's bring up a guest from Discord. Let's bring up Abdullah Musa. Abdullah Musa, how's it going? Oh, I should have answered some questions first. I'll answer some questions after this. Abdullah, how are you? Abdullah? Well, that's as convenient as possible, so let's read some questions and we'll bring up another guest. They might have just been working. Okay. Some really big dude. Okay, so those aren't questions. That's not a question. I know which me is having this experience. It's definitely this me. Good point. Yeah, that's a good point. All right, let's bring up middle. I didn't get a chance to read the rest of the name. It's quite long. Middle Takiyanagi. Oh, and he's gone. Okay. Let's bring up Rolando. Rolando, how's it going? Rolando, you there? All right. Seems like he's not here. Let's bring up Abdullah again. Abdullah Musa. Abdullah Musa, welcome back.
Hello.
Howdy.
Hello.
I'm currently hearing myself. If you could, I don't know, take me off speakerphone or something, that would be really good. But what questions you got for me?
Well, first of all, I want to acknowledge you for taking your time to help answer all these questions. First, I asked a question about Compton scattering and visible light, because I read in a textbook that Compton scattering is a bit odd in the sense that it's almost like shining blue light on a surface and then it's reflecting with a different color. So I thought Compton scattering is a property of X-rays and some surface. It's an interaction that you observe when X-rays are shined on some surfaces.
I mean, look, so I can just help you out here. So Compton scattering is just the name for any photon electron scattering phenomenon, right? That's just what photon electron scattering is called. And so, like, I can just show you the diagram if you want. Let me pull it up. I don't want just that one. Okay, I'll just show you the window that I'm looking at. Here's the Wikipedia page on Compton scattering. So Compton scattering is just either of these kinds of processes where time runs from left to right. So you have photon comes in, electron comes in, they scatter, photon goes out, electron goes out. That's what Compton scattering is. That's all it is. Now, the probability, and by the way, yes, it is the case that the photon energy is not conserved. You can just compute the photon energy after the collision and compare it with the photon energy before the collision. And so, like, for example, actually it says it right here. Here is the photon energy after the collision. And so, you know, it is different, but this is not something that's restricted only to X-rays. Now, it might be more probable for X-rays, and if we wanted to check that, we would have to go and figure out what the scattering amplitude is, which we can probably just Google, I think. So tree level Compton scattering amplitude. I should be able to find this. This is the kind of thing that you derive in a this is the kind of thing that you derive in like grad school in like a quantum field theory course. But the point is that like there's going to be some formula that tells you the probability of Compton scattering happening at some angle. And what you'll find is, and what I suspect you'll find is that it's proportional to the energy of the, it's proportional to the energy of the incoming photon. And so it's more likely to happen for X-rays, but it's not like forbidden as far as I'm aware. There's no reason why it would be forbidden for lower energy photons. Okay, I think I found it. Does that make sense?
Yes, yes. Because it's more likely to occur with higher energy photons than.
Yeah, that at least that's what my intuition says. Of course, you'd actually have to do the calculation, and it would be like a tree level. You could probably just ask like ChatGPT this, to be honest. Like derive for me the let's just try that. Let's just punch that in. What is the tree level scattering amplitude for Compton scattering? Let's just, and you know, if it takes too long, I won't worry about it, but it might just be able to give me the answer pretty quickly by finding a source. But the point is that like this is just a calculation to do.
Then also, can I go on to another question?
Yeah, go ahead.
You said dark matter is likely slow and heavy. Like
Sorry,
I don't.
Sorry, I didn't follow that. Can you repeat that one more time?
When I asked the question about dark matter, you said it's likely it is slow and heavy.
Yeah.
So I don't understand what are the reasons why we suspect it's likely to be slow and heavy.
So, and you know, it's a little bit involved, but basically, when you go out and you look at the so there's kind of two things that it could be. I mean, of course, perhaps more than these, but like you could have like light and fast, or you could have slow and heavy. And so the point is that if you look at the way that light and fast dark matter would behave, it just doesn't match our observations about like the kinds of halos that are formed around galaxies. For example, like halo formation is the kind of thing that requires slow and heavy particles rather than light and fast particles, because light and fast particles are going to have a harder time coalescing rather. And so it's that kind of thing. Like there are different gravitational dynamics between things that are light and fast and things that are slow and heavy. Like one way to see this is it would be like imagining that like dark matter is actually like made of like light particle or like photons. It's not literally made of photons, but like imagining like that. Well, why would the photons have enough gravity to like clump up into bunches? Whereas if the dark matter was made of like literal dust, then there would be gravity to clump up into bunches. And so that's the kind of reasoning that can be used.
Another question.
Sorry, one more time. Can you repeat that?
Another question, or that's the end of it?
No, you're fine. You can ask another question.
Okay. I asked about the
Sorry, I can't hear you. You there? When you're off the app, I can't hear you, by the way. By the way, ChatGPT is giving me this Compton scattering. Actually, and I guess it gave me the name of it. The name of the formula is called the Klein-Nishima formula. What's up? Hello. Oh, okay, thank you. Yeah, okay, actually, here you go. This is the formula that you want, the Klein-Nishima formula. So this is the probability. It gives it's the differential cross section, and I don't know if he's still here, but it gives the differential cross section for photons scattered from a single free electron. This is what you're talking about. This is Compton scattering. Oh, okay. So I see what the distinction is. There's a confusion. This is just a language term. It's the same thing. It's the same underlying thing, but I guess Compton scattering is specifically used to refer to the thing when it's high energy, whereas Thompson scattering is used to describe the thing when it's low energy. Okay, so you're right. Compton scattering is defined to be the kind of electron-photon scattering when you're high energy. You're right. You were absolutely on the money. But the point is you still get photon-electron scattering at all energies, and the scattering cross-section is this. So the higher or the shorter the wavelength, and in fact, this is actually probably like, you there?
Yes, I'm listening. What I was getting to was that it seems to me Compton scattering is there isn't how do I say it? The collision is inelastic, whereas Thomson scattering is elastic. The collision is elastic, and that's really. I
don't think Thomson scattering is elastic. I mean, it might be just okay. So it says that it's elastic, but like in principle, like you can't have. It's not like truly elastic, right? Because the point is that if you have a photon scattering off an electron at rest, in order for scattering to happen, the electron has to gain momentum, right? Otherwise, there's no scattering that happens at all. Now, it can be approximately elastic because it can gain a very, very small amount of momentum, but it still won't be truly elastic with regards to what the photon's energy is. Now, it'll be elastic in the sense that energy is conserved. But yeah, maybe you can get to the underlying question that you were trying to get at. Because if you were aware of Thomson scattering, then like you understand that electrons can scatter off of or photons can scatter off of electrons, no problem, right?
Yeah. What I was getting to was that Thomson scattering appears to be more of an elastic collision than Compton scattering, and so I don't really understand why is that so. So the higher the energy of the photon, the more inelastic the collision is likely to be. Or
you mean the more that the photon will lose energy?
Yes.
It's my guess is it's just the like, and we can go back and we can look at the like the, not the probability, that's not what we want. I mean, we kind of do want the probability. You can just look at the scattering cross section for different ratios, right? So the relevant thing is the ratio of the wavelengths. So, which is related to the ratio of the energy levels. And so what you'll find is that the ratio gets bigger the larger the scattering angle, right? It also depends on this dimensionless quantity, which is handy, I suppose, which is the energy of the electron compared with the energy of the photon. And so if epsilon is quite large, i.e. if you have a high energy photon, then the denominator will get quite a bit smaller because you have a larger contribution from epsilon. And so that means that the ratio will be further from 1. Whereas with low energy photons, if the energy of the photon is quite low compared to the mass of an electron, then what you'll find is that epsilon is quite small. And so if epsilon is quite small, then regardless of the scattering angle, the ratio of the photon wavelengths, so the ratio of the photon energies, will be quite close to 1. So it all has to do with that dimensionless quantity is the important thing.
Okay, yeah, I get. And since we're on this, I want to ask: is Wikipedia a good source for physics?
For stuff like this, yes, absolutely, yes.
And also, there's a textbook. I don't know whether you are aware of it, called Young and Friedman University Physics.
Yep, I'm very familiar with Young and Friedman.
I think the statement I was talking about, I think I got it from Young and Friedman, but I can't quite find the page or the area where I got that.
The thing about Compton scattering?
Yes.
So Young and Friedman is not going to be Young and Friedman is a very basic book, so it's going to make a lot of simplifying statements. So like if you want to if you want to look at this like in more detail, you should look at like particle physics textbooks.
Okay.
Does that help?
I said we were talking about gluons and the strong force and how it's analogous to the virtual photon in quantum electrodynamics before you got your prompt from ChatGPT.
Yeah. Go ahead and ask.
Yes, I said is the analogy that the gluon is analogous to the virtual photon in quantum electrodynamics, like the same as the gluon in quantum chromodynamics?
Well, sort of. So the gluon is analogous to the photon, except the dynamics, the features of quantum chromodynamics, as far as we can tell, forces gluons to always be virtual, if you will. Right? You can never get freely propagating gluons, as far as we can tell. Now, this hasn't been mathematically proven, as Quanta is very, very wont to say, but the point is that like we've never observed these things, and we have good reason to think that you can't get freely propagating gluons. So all of the gluons will always be virtual, despite them being analogous to photons, which can often are real.
So what I'm getting into is that a gluon is a real particle, but just like in quantum electrodynamics, when we see the interaction between charges, you can be represented as them sending virtual photons between each other.
Mm-hmm.
Does that mean the interaction between quarks is also can also be represented by quarks sending virtual gluons between each other?
Yes, it's exactly that.
So that gluon, is it real, or it's you can have you can see a gluon, but you can have a real gluon, but not. I don't really understand. I don't know how to frame the question. What I mean to say is that in the labs, have we observed gluons?
No, and we suspect that you probably can't isolate a gluon.
But are there evidence that the gluon is a real particle?
There's evidence that the gluon field exists. And once you have a field, then like the particles are just excitations of the field. Like once you have the field, then there's not much else to do, right? But the point is that like you don't see free gluons flying around.
Okay.
Abdullah, I'm gonna let you go. Oh no, never mind. Okay, you're good. If you have another question, that's fine, but otherwise I'm gonna let you go and bring on another guest.
No, I do have another question.
Oh yeah, okay.
So I don't know what
It'll have to be the last one, but go ahead.
Okay. When you oh no, let me ask you this one question. With regards to the mass of the proton, regards to the mass of the protons and neutrons, I had in this we say the mass is not gotten from the Higgs field.
Right.
Most of the mass it's gotten from the energy of the quarks. So I don't really grasp that. And
so here's an analogy. If you have a box, say you have a box that's lined with mirrors, like perfect mirrors on the inside of the box, and then you just turned on a light bulb, or you had the light bulb that was off, right, inside the box will weigh a certain amount. And then if you turn on the light bulb, the box will now technically weigh just a teensy tiny bit more. So you turn on the light bulb, then you turn it off, and then the photons are still bouncing around, forever, or whatever it is. The box will weigh slightly more, because even though the photons don't have mass, they do have energy. And from the box's reference frame, there's no reference frame that you can choose so that all of the photon energy goes away. And the same is true for the quarks in a gluon, or the quarks in a proton. In the proton's rest frame, even when you're as close to rest as you can get, the quarks still have kinetic energy, and so that energy is what we call mass, or at least it contributes to the mass.
So what you are saying is that a particle can have mass irrespective of its interaction with the Higgs field, or through another mechanism other than interaction with
a fundamental particle can't, as far as we can tell, but composite systems can.
Okay, and also when a particle approaches relativistic speed and approaches the speed of light, and then its mass increases.
No, that's not really how we understand these things anymore. We never really talk about mass changing with speed.
Okay.
Well, yeah, I mean that's the kind of thing that was taught prior to like the 50s. Nowadays we talk about mass as being invariant. Mass is just how much energy a thing has when it's at rest. But what we can say is that the momentum changes non-linearly with velocity.
Okay. So it appears as if the mass is increasing, but it isn't.
Yeah, the mass is invariant, but the momentum it increases non-linearly.
Okay, but does that increase is that sort of another mechanism of increasing? Okay, you said it doesn't affect the mass. Okay, I think that's it. Thanks for that.
All right, I'm gonna let you go, but thanks for being here. All right, let's answer some more questions, and we'll bring up another guest. This time from Discord, we'll bring up Generic. Just want to make sure that I don't miss any questions in the chat. What's something you wish everybody understood about geometry? I don't know. That's probably one of the questions that I should answer when I'm trying to write my book. If I ever do write the book. Like, who knows? Maybe I will, maybe I won't. But that's a good question. I'll have to think about it some. Please make use of your superfan subscription, so request up or ask your question in the chat stream. True. Do you have any pro tips for science outreach? I volunteer at a local observatory, and it's a rough time these days to compete with science bros who want to be relevant but not compromise with science. Yeah, I don't know. I think that, so at an observatory, so one of the things that I think is valuable, it's not the only way to do science communication, but one of the things that I think is quite valuable with regards to science communication is when you have people in the field, people who are scientists who actually like know the astronomy or know the physics or know whatever it is, read a new paper and then tell people about it without lying about what the paper's about. Like, giving the ideas of what's in a paper is valuable. And if you're in the field, you'll be able to do that correctly. You'll be able to do that in an accurate way without compromising the science. And science pros are not able to do that. And this is a niche that, actual science communicators, like people who are, involved in the actual science, this is like a niche that only they can fill. So that's something that you could try. Would the proposed black hole stars have jets at their poles? I don't know. I haven't looked into them. What does it mean when a physicist describes space as flat? So there is a particular notion of flat that we're talking about here. What we mean is that it has no spatial curvature. Now, this is a three-dimensional notion, not a two-dimensional notion. But curvature is basically measured by what we consider straight lines to be. And so if we say that space is spatially flat, that means that if you took away all of the matter, it would still be true that parallel lines always remain parallel. Whereas if space was curved intrinsically, even if you took away all of the matter, parallel lines would not stay parallel forever. They would eventually intersect. What would be the conserved quantity of a scale invariant universe? I guess there'd be a charge associated with it. Like a conformal charge. I don't think that we have a name for it, though. How do we differentiate gravitational lensing done by an isolated black hole and isolated dark matter? So it's not clear that we really do. Like, if you can't resolve, I guess it depends on how big the thing is, right? So like, generally, with regards to like dark matter gravitational lensing, it's like really diffuse. right? Because the dark matter is really spread out. Whereas from a black hole, it'll be very, very significant. But if the dark matter is very, very like highly localized, then you couldn't tell the difference. Unless you have extremely good telescopes, then you could see like, because then the black hole is smaller, and so like the dark matter, even if it's extremely compact, would still be less dense than the black hole, and so you would still see different gravitational lensing effects. Where are my perks and why is it $6.99? You said it was $5 per month. It shouldn't be $6.99. Let me pull it up. 1 sec. I'm going to, so you are on YouTube. I should go to YouTube and I'll go to view your channel. I actually don't know what channel you subscribe to, but we can look at both. So, click there, memberships, levels. So on the Dr. Blitz Debunks channel, it's $5 a month. And on the Blitz PhD channel, let's check, make sure that nothing changed without my permission. Yeah, it's $5 a month there. So I don't know where you're seeing the $6.99. Maybe if you're in Australia, it'll like, because like maybe it like translates from different currencies. So it's like 5 USD, but maybe in like Australia it's like 7 USD if the Australian dollar is weaker. I don't know. But once you have become a member, and I can just double check. I'm just double checking which one you became a member on. I can check this for you. Apologies, by the way. Apologies for the trouble. So happy, wait a minute. Okay, so I don't see you on the Dr. Blitz Debunks. I didn't see you on the Blitz PhD channel either, but I'll double check again. Yeah, I don't see you. Oh, Happy Mansplainer. Okay, I see. Yeah, it says $5 a month. You should have, wait, where'd it go? Yeah, it says $5 a month. You should have all of the perks if you're on YouTube. If I go to my, yeah, you should have the loyalty badges, you should have emoji, you should have the members only debate notes access. You should also, if you want the Discord only chat, if you want the members only Discord channel, you have to join the Discord server and then you'll get it there. But yeah, so it says that the perks are there. So I don't know what's going on, but apologies. If you want to DM me, I'm sure we can figure out what's going on. Do you think it would be appropriate to say that arithmetic is derived from the geometry that is apparently facilitated by interactions? Oh, that's hard to say. I don't know. I am in US and it was $6.99. That's troubling because I only have one level of membership. And I can just show you what I'm seeing. I want to make sure that there's nothing that, yeah, let me show you what I'm seeing. So this is what I'm seeing on both places. So this is the membership offer. It's disturbing that it's charging you $6.99 because see how it, like I only have the one membership level and it's $4.99. So that's kind of disconcerting. Yeah, hopefully we can try to fix this because that would be a little bit surprising. It definitely shouldn't be $6.99. All right, let's bring up a guest from Discord. Let's bring up Generic. Huh. Maybe it's because of Apple. Maybe it's an Apple thing. Because like I don't see the $6.99 anywhere, but maybe Apple's like charging an extra $2 or something. I'll look into it. I'll look into it and see if like YouTube charges more than what I set it at. I'll see if that's a thing because that would be really annoying if that were the case. Generic, how's it going?
Good. How are you? Can you hear me?
Yeah, I can. What questions you got for me?
Yeah. So I might be having a misconception about like universal constants and like modeling the universe in the context of the fine-tuning argument that theists use. So from my understanding, it's very basic. And for context, I do a lot of numerical simulations, but using models, but just not with physics. And
Sure.
they're not typically brought up in, the fine-tuning argument.
Mm-hmm.
But these models, right, are developed, and then we use the constants to basically tune the models so they agree with our observations. Is that fair to say?
Yeah.
Okay. So a follow-up question is like the way that the theists are using the fine-tuning argument sort of doesn't make sense because our models aren't perfect, right? So if you tune these constants, you're just screwing with the model, which already doesn't perfectly describe the universe.
That's true.
So it's so their argument is like sort of dead on arrival.
Yeah, it relies on assuming that like these constants are like fundamental features of the universe rather than like, features of like our best current model. Now,
Okay.
what would be reasonable is like if we have a model that's like a final theory of everything that like actually is correct always, and you just have to figure out what the constants are to make it correct. If it is then the case that the constants are like very unexpected, then that might be puzzling and that might deserve further investigation. But as it stands, yeah, like there's an assumption that these constants are somehow fundamental, and I don't see any reason to think that that's the case at this point.
Okay, yeah, because I get irrationally angry when somebody brings up the fine-tuning argument, and I'm like,
Fair.
they're not knobs to twist. They're constants that we found that make our models agree better.
Yeah, I mean,
Okay.
I guess the point is they kind of assume like there's some sort of reality about them that like that there could have been universes with, or that somehow our models are like correct, and they're correct in the way that you could have had a universe where the models are the same, but the constants that appear in those models are different, and then that would accurately describe those universes. That's kind of the assumptions that goes into this, and I don't think that that's particularly well justified.
Okay, well, thank you for your time.
Of course. Sorry to keep you waiting. Have a good one.
I don't know. You too.
We have $5 from Garain. If the observable universe is underdense compared to the total universe, could dark energy be gravity surrounding mass pulling it in every direction? No, because it's happening everywhere, right? It's happening everywhere. It's not just happening. It's not just like the point is that there's like a linear relationship, right? And it's happening less as you go further back in time too, which is kind of surprising. It's definitely something. It's not just ordinary gravity. Might be Canadian dollars. No, I don't think it's VAT either. He's looking at the super chat price, not the membership price. No. He's looking at the membership price. Somebody sent me a screenshot from their app store with the membership price, and it says $6.99 a month. And that's very weird. I don't know why that's happening. Why are the largest black holes more massive than the largest stars? Well, so the largest black holes are supermassive black holes. And supermassive black holes formed in a different way than stellar mass black holes are. They formed probably by direct collapse in the very early universe. And so it's just they formed a different way. That's why. And stars kind of have an upper limit as to how massive they can be, at least in the current universe. They can be like a few hundred times the mass of the sun and not really any bigger. Then we have from whoever is in the US getting charged $6.99 probably has crop credit. No, I don't think that's the case. Apple does that. I heard another creator mention this. Oh, okay. So it could be an Apple thing. Let me shut the door. Apple takes a charge too. I just remembered like a war story. Yeah, that could be. So that could be the explanation. A credit card may charge for under $5 or $10 purchases. That is on the provider, not me. No, we observe the constants. No, we fit the constants. So you can't observe the constants. You have a model, and the model has constants in it, and then you change the constants until they match your observation. I'm also only seeing $5 on mine. I looked into it. Apple indeed charges 30% on top of membership subs and premium subs on YouTube. Okay, that's good to know. So this is an Apple issue. Okay. What gets weirder in higher dimensions, triangles or circles? Definitely circles. Circles get weirder. They're definitely the source of the weirdness. But to be honest, if one thing gets weird, they all get weird. I just got to double check something, make sure that I'm not missing a meeting. Okay, cool. Not missing anything. Okay, let's talk to Quantum Person. Quantum Person, you gotta connect. Yeah, you gotta pay the Apple tax. It's rough out there. All right, it looks like Quantum Person's not connecting. So I'm gonna bring up Beaver. That was weird. Beaver's not connecting either. What is happening? Okay, there we go. Beaver, how's it going?
Oh, hello. Okay. Hey, I was just gonna ask, do you think that it's plausible that the universe has always existed?
Yeah, I think so.
Okay. Do you agree with all the laws of thermodynamics?
Yeah.
Okay. Do you think if the universe has always existed, do you think it'd be plausible that energy would have reached an equilibrium?
Only if it's been in a kind of a stationary state for that long, yeah. But if it hasn't been in a stationary state, if it's been evolving, then no, not necessarily.
So given enough time, wouldn't it have reached a stationary state?
Only if it hasn't been evolving. Only if it's, only if the space-time is not dynamical forever.
So you're saying that energy can evolve for an infinite amount of time?
No, I mean like space-time, the evolution of space-time. But like, yeah, in principle, sure.
So you're saying that. So how are we going to know that the universe, like using these same laws of thermodynamics, we know that that the universe used to be in a hot, dense state?
We don't really use thermodynamics to do that.
Well, no, we can calculate the how energy has moved and how it's
we don't use thermodynamics for that. We use general relativity for that.
Okay, so could you tell me like expand like how it would work for a infinite universe or like an eternal universe for energy not necessarily being in an equilibrium from an eternal universe? Like, just expand on that.
Yeah, so there's and I don't want to give away too many details, but like one could imagine, for example, and actually let's just back up. So there's something called the Poincare recurrence theorem, which is it's just a theorem of classical mechanics, but there's also like a quantum version of it, where the kind of the canonical example is if you put a gas in the box, or if you put not a gas in the box, if you put an apple in a box, eventually it'll and make sure that the box is completely sealed, completely isolated from its outside environment, so it doesn't give off any energy. It's just completely sealed. Eventually the apple will decay away. It'll dissipate into a gas and maybe some like smudges of carbon and stuff, but so long as the energy content of the box is unchanged, then the system will continue to explore possibilities essentially randomly. And one of those potential configurations of its matter that is allowed by the total energy of the system is a configuration that is an apple again. And so just by randomly rearranging itself enough times, eventually it'll end up in a low entropy configuration. So what the second law of thermodynamics is about is it's a statistical law. Namely, it says that like generically what you expect to happen is that entropy will increase. But it doesn't say that it's impossible for it to decrease. It just says that the larger the system, the lower likelihood it is that it will decrease.
Okay, yes, that does make sense. But do you think that the universe is like a box to where it's like finite?
Could be. The data that we have is consistent with both being infinite and being finite.
Okay, but do you think that, for that analogy, do you think that only works for if you could equate it to being like a box, to where it's contained enough for it to be a possibility instead of it, being infinite?
Entropic recurrence essentially requires that there's a finite number of possible states.
Yeah.
Because then the idea is that, if there's a finite number of possible states and it explores them randomly, then the probability of exploring every possible state is 100%. Whereas if you have an infinite number of possible states, then it really depends on how kind of the comparison between the amount of time that you have and how large the infinities are and things like this. So it becomes a lot less clear. However, if the universe is infinitely large, then there's not really an entropic problem to begin with, because the universe's entropy is already infinite, and it could be the universe's entropy could be infinite forever, and it could be growing forever, and you would never have an issue, right?
Okay. I was just asking that just because I was wondering if there's maybe some evidence to go based off there. But yeah, okay. Thanks for answering my question. That was a fruitful conversation.
Yeah, of course. Oh, he left. We do have do we have any questions? No, we don't have any questions, but we do have Migraine becoming a 4-month tier 1 subscriber. I appreciate that, Migraine. Or Migraina. Very appreciative of you. Now we have Amna, who wants to come up and ask some questions as well. Amna, how's it going?
Good, how are you?
I'm doing all right. What questions you got for me?
It's related to your major, if I could ask about that.
Sure, I'm not still at university, but sure.
Yeah, I just wanted to ask, your knowledge, oh my god, it's insane. It's so cool.
I appreciate that. I just wanted
to, did you get all this knowledge, did you obtain all the knowledge from university because you have a PhD, or was it more like books and research?
A little bit of both. So you definitely learn a lot when you do a PhD, and when you do an undergrad in physics, you learn a lot of information. But I probably have a slightly broader knowledge base than a lot of people who have PhDs like I do, just because I also spend a lot of time communicating physics. I do science communication as well, so I have to learn a lot more broadly than what a deeper specialist might. So that ends up I end up reading a lot of research papers. I end up that kind of thing. So
okay, thank you so much.
Of course, thanks for being here. Nice pronunciation in Polish, Migrena. Did I pronounce that right? Okay, I'm glad I did. I'm actually going to be in Warsaw in 2 weeks, sometime in the middle of September, for a conference. That's a babe, but we're going to pretend we didn't notice. Indeed, we will pretend we didn't notice. Jerk just became a super fan. Welcome to the party, Jerk. Glad to see you here. It's always good to see you. He had to eat a lot of brains to get to this level. It's true. I did actually. Well, y'all, we are out of questions. We are out of guests. We have McTime, but McTime comes up all the time. I guess we can bring up McTime. As long as it's short. Because I actually need to go fill up my water and drink some coffee. I have a meeting in a bit, and then I have some other stuff to take care of before 1 o'clock. McTime, welcome back.
Oh, hold on. Let me turn the TV down. All right. I got a couple of questions for you. I took the time to write it down. Let me first state that your knowledge is vast, but your taste is bad. So.
Likewise.
All right, but first question is that last caller you talked to, he was talking about the laws of physics and stuff. Do you share that opinion that naming them laws and universal concepts, that's a misnomer? I don't
really care what they're called, to be honest.
But I understand, but it just seems like it's very it irks me that a lot of people try to use the fact that they're called laws and constants to predict to prescribe the universe with their imaginary God. And
I understand the desire to reject these names. I think that maybe that's the case, that if they were named something different, then that would have reduced confusion. But now I think it's just our job that we should just explain things.
Okay. The second question is this might be a little funny, might laugh at it. you know, like you know how every great thinker in science have demons. Like you got Maxwell demon, Laplace demon.
Yep.
If you, what demon would you have, and what would his power be?
It would be a flat earther who has the power to make the Earth flat.
All right. And my third question is what's your thoughts about the Spud cell? You know, you this unfair question. I know biology ain't
I
your
haven't
field.
I
Do you
haven't
know
looked at it at all. I haven't looked into it
Okay.
whatsoever. I probably should, but I haven't.
Yes, sir. And I got one more. My final question. I know your time is short. As my only Jew friend that I have, what do you feel about the Christians using, you know, trying to lump their religion onto the Jewish? I know you're not a practicing Jew, but how does that make you guys feel? 'Cause it makes me feel.
We don't like it. We don't like it at all. It's very it feels very like so and look, like I still feel this way even though I'm not practicing, even though I'm not like religiously Jewish, because what it feels like is that like they treat Jewish people as like this ancient people of old that are like, you know, not actual people that still exist. And then they're like, oh well, we are what followed after that. Like, no, you're like a break-off group. There's still Jewish people here. It is very frustrating.
It pisses me off, and I'm a black person, but it just pisses me off, and I know I don't want to be madder than you guys, but and so whenever I hear they talk about this stuff, I make sure I point out.
You can be just as mad as you want.
Well, I make sure I point out about Justice Smith and the Revelator that if Jesus is your Christ, then Joseph Smith is your Revelator. But that's it.
There you go.
I don't want to take too much of your time. Thanks for talking with me, man.
All right, take care. All right, so we are now. Oh, okay. We do have some comments. To avoid extra charge, sign up for the membership on the website and not from phone. Yeah, that's probably what you should do. That's a good point. I try to say the behaviors of the universe instead of the laws of the universe because of that weak argument that a law requires a lawgiver. Yeah, I mean, I just try not to be too wordy. I just try to, like, if they use that argument, I just try to convey what I mean by law. You're right, law doesn't really have a consistent definition in science. That's true too. Christian religion is a successful spin-off TV show. There you go. It's like Young Sheldon. More people know about Sheldon Cooper from Young Sheldon than they do from The Big Bang Theory, I think. Despite how wildly successful The Big Bang Theory was. Which is, you know, it's just kind of crazy that that's the case. All right, so I'm going to end the live here because we are out of guests, we are out of questions, and I have some stuff to take care of. In particular, I have coffee to make. So I will see you guys tomorrow for some more debates. Until then, make sure that you consider subscribing, you consider following along, or, you know, becoming a member, or any of these nice words that make me feel good about myself and help me with income. Until then,